Hello wonderful person, this is Anton, and today we're going to be discussing some of the new discoveries about the unusual poofy planets. Various unusual planets discovered in the last decade that for some unknown reason seem to be extremely low in density. Or to be more exact, seem to actually have relatively small mass but incredibly large size. Sometimes even larger than Jupiter, despite masses being relatively low, comparable to a planet like Neptune or just several masses of planet Earth. And though for the most part their existence is still a little bit mysterious, we're now getting just a little bit closer to cracking the mystery of how they exist and why they're so extremely large. And this is actually based on several new studies, with one of them involving the James Webb Space Telescope that's finally been able to do something we've never been able to do before. But before we discuss these specific details, let's briefly discuss exactly what these planets are and how they differ from one another. Because even though we call all of them poofy planets, there are a lot of individual differences. And here's actually one of the most recent discoveries from just a few days ago. A new planet, WASP-193b, that's about 50% bigger than Jupiter, but by mass seems to be the second lightest such planet ever discovered. In this case classifying as the extreme version of a poofy planet, also referred to as a cotton candy planet. Yeah, these names get really funky. And so the discovery of this planet actually raises more mysteries. Here the assumption is that it's mostly made out of hydrogen and helium and seems to be at the maximum possible size. Or essentially it reaches what's known as the Roche limit, where basically as it gets bigger and bigger, the gas from the outside gets captured by the star and escapes into outer space. Although to be more exact, this is known as the Roche lobe and resembles something like this. So we have this star right here, with the planet reaching its maximum size. And because the mass of this planet was so extremely small, it actually took 4 years to even calculate it. In this case, this is done by using what's known as the radial velocity method, or essentially observing how the planet influences the motion of the star. It basically creates a tiny wobble in the star's orbit, which is usually how we calculate the mass. But in this case, because this particular planet was much lighter than other planets, despite its huge size, it was extremely difficult to see any of this. Nevertheless, the researchers, whose paper you can find in the description, were finally able to confirm that this is one of the most extreme poofy planets or cotton candy planets ever discovered. But it still doesn't tell us why it's like this. Here it's actually only assumed that this is because of light gases. And on top of this, the idea of these poofy planets is also somewhat vague, because here we're actually combining completely different types of planets. For example, here is an illustration of what's known as a superpoof. In essence, a planet that's maybe just a few masses of planet Earth, but usually possesses a size of Neptune or even more. And these are generally much cooler in temperature, possibly 100 to 300 Celsius, and thus potentially represent their own type of a planet. In contrast, these cotton candy planets are usually much larger, bigger than Jupiter, with the overall mass several times larger than what we have here. And so here it's not entirely clear if they all have the same origin, and if their size difference is caused by a different mechanism. For example, some explanations here involved just observational bias. For example, maybe what we're observing is not the actual planetary size, but instead some kind of a gas streaming from the surface of the planet that makes it appear much larger. Or, as suggested by some other studies, maybe what we're observing are actually rings. And in this case, huge rings that seem to engulf the planet, making it appear large from the outside. But in most cases, all of these planets seem to be relatively close to the star and also seem to be relatively hot. And so it was always assumed that it was the heat from the star that inflated their atmosphere somehow. We don't really know how yet, but that's basically what one of the studies we're discussing today try to tackle. But in some cases, even if you take temperature into consideration, quite a few of these planets are still larger than they should be, with some additional explanations essentially trying to explain this using still unknown chemistry in the upper atmosphere, or maybe the interaction between atmospheric winds and the planet's magnetosphere that creates various electric currents, heating up and expanding the planet. So essentially maybe this is all a result of some kind of a atmospheric ionization, basically making these planets strangely electric, superheated and very expanded. So in essence, at least for now, there does not seem to be one explanation for all of them, but we might finally have an explanation for at least one of these planets. WASP-107b, a planet 200 light-years away from us, discovered back in 2017 that seems to have an unusual misaligned and eccentric orbit that takes approximately 5.7 days. And though the planet is about the same size as Jupiter, it seems to be only about 1/10 of its mass. So once again, this is a super poof or just a general poofy planet. And back in 2018, this was actually the first time researchers found helium around any exoplanet out there. So we know this planet definitely contains helium. With additional observations in 2023, also discovering water vapor, sulfur dioxide, and even a few silicates inside the clouds, with these early observations establishing this planet as a perfect candidate to study the atmospheres of these very unique, very unusual planets. Which is exactly why James Webb Space Telescope just took another look at this planet, discovering so much more in the process, with these new discoveries visible in this graph. And there are actually a few surprises. First of all, this definitely confirms water vapor, sulfur dioxide, and various silicates. But even though the researchers expected a lot of methane, kind of like what we have on Neptune and Uranus, here they discovered almost none, or to be more exact, about 1,000 times less than expected. And so there was some methane, just very small amounts. And in one of the studies that you can find in a description, researchers explain this as one of the potential explanations to why it's so big. Here they basically suggest that methane very likely transforms into something else as it flows upwards in the atmosphere and very likely interacts with a lot of other chemicals and also obviously starlight, which causes gases to change, destroying methane in the process, and surprisingly elevating the amounts of carbon dioxide and carbon monoxide, both of which were discovered in these new observations. Surprisingly, unlike expected, this planet also contains way more heavy elements, even more than Uranus and Neptune, potentially suggesting that this planet is actually really hot on the inside. Or basically that it has a relatively hot core, which is also very likely extremely massive. Which is a little bit counterintuitive, as almost the opposite was expected at first. Very small core, a lot of light gases, and thus a large size. Instead, here, the core is assumed to be approximately 11 to 12 masses of planet Earth, and is very likely super hot, potentially representing the main source of heat, with the star in this case only providing a little bit more. And this explains how and why this planet exists and why it's the way it is. Because having a small core with a lot of hydrogen and helium is actually really difficult to explain. A typical planet should not be able to acquire so much gas if it has a relatively small core. But here, by having a large core, this planet was able to accumulate a lot of gas, and by being super hot on the inside, it then basically creates a lot of additional chemistry and a lot of additional circulation inside the atmosphere, which mixes a lot of gases inside and creates a lot of chemistry we still don't really understand. And so it's very likely superheated gas from inside the planet that actively mixes with various layers that seems to first of all destroy methane, which is usually unstable at high temperatures, but second of all expands the atmosphere of this planet, making it poofier than it should be. But despite this core being twice as large as initially assumed, it still does not explain why it's so hot. The star cannot in this case make it so hot, so something else has to be responsible for all of this. And here the answer is in its unusual orbit. As previously mentioned, this planet seems to have a somewhat eccentric orbit, and there's also another planet in the star system that pulls on this planet as well, which essentially results in what we refer to as tidal heating. This is what we usually observe on objects like, for example, Io around Jupiter. And so it's really the tidal heating caused by this unusual orbit that's most likely responsible for the superheated core. And that superheated core is then responsible for inflating the planet. And so here the explanation seems to be somewhat simple. You have an object similar to Neptune with a much larger core containing rock, or basically silicates, but potentially slightly less gas. But this core is superheated by tidal forces from the star and from the additional planets, with all of this heat escaping by causing the upper atmosphere to expand and to start mixing vigorously, initiating a lot of additional chemical reactions, but also poofs up this planet so much that it becomes almost Jupiter-like in size. Or at least that's the initial explanation from two separate papers that you can find in the description below. But even more importantly, here we finally have proof that the James Webb Space Telescope can actually reveal information about not just the atmosphere and the composition of a typical planet, but also help us understand what's inside of it and analyze its core, which means that it's very likely that in the next few years, by analyzing additional poofy planets and a lot of those other low-density planets, we might finally have more answers about how they form and why they exist in certain star systems, but not in others, and actually why these planets are somewhat rare and none of them exist in the solar system. Although I guess, at least for now, we can only assume that they do have different formation mechanisms, and not all of them are the result of a hot core. This one seems to be, but this mechanism is unlikely to explain the ones discovered in other star systems. So, a few hours ago, from when I'm making this video, NASA officially announced a confirmation of yet another super exciting exoplanet that seems to be both terrestrial, but also potentially habitable because of its orbit. But even more importantly, it's relatively close to us and can also be observed by a lot of telescopes, including the James Webb. And so, hello wonderful person, this is Anton. Let's discuss the discovery of Gliese 12b, focusing on why this is actually kind of important, but also focusing on what this planet might be like, and what the surface of this planet could maybe look like. Now obviously a lot of these questions don't actually have answers yet, but because of the way this planet orbits around the star, we're going to have a lot of these answers really soon. But to begin, okay, so let's talk about the star. As in many other star systems, this is the most common star in a galaxy. This is an M-type star or a red dwarf. It's about 27% the size of the Sun and has a surface temperature of about 60% of the Sun. So in essence, not too hot and not too big. But in all of the previous cases, red dwarfs had one major problem. Very often they were exceptionally active, producing a lot of emissions and a lot of flares, and because they're generally much more magnetically active than the Sun, they would result in frequent, very powerful X-ray flares. Like, remember those flares not so long ago that the planet Earth survived? So yeah, that times 100 or even 1,000. And unfortunately, this was one of the biggest disappointments with the nearby Proxima b, the closest star system to us, that's about 4.2 light years away, that potentially contains 2 planets, and one of them is terrestrial, in the habitable zone. But Proxima b is super active and produces a lot of really powerful flares. One of them possibly even fooled us into thinking it was alien communication. And these flares are powerful enough to almost completely strip the atmosphere from these planets in just a few million years. Now the most exciting star system discovered so far, TRAPPIST-1, is also a red dwarf, but so far seems to be not as active, and so there are some chances that maybe some of those planets might have something on them. But what about this newly discovered system, Gliese 12? Turns out, and this is a direct quote from the scientists, it seems to have one of the lowest stellar activity levels known for M-dwarf stars. Or just to rephrase this, it actually seems to be one of the least active red dwarfs we've ever seen. Basically implying that this particular planet does actually have a chance to maybe retain some atmosphere. Now we know that in the TRAPPIST-1 system, the nearest 2 planets, TRAPPIST-1b and TRAPPIST-1c, appear to be barren. And that's probably because they're just so close to the star. But what about this planet? How does the orbit compare here? Well, here the analysis suggests that it still seems to receive a little bit more radiation than planet Earth, actually approximately 1.6 times more, but a little bit less than Venus, maybe about 85% of what the Venus receives. Which basically implies that its equilibrium temperature is a little bit hotter than Earth, but cooler than Venus. And so here everything depends on whether it has the atmosphere. And so here on Earth, the equilibrium temperature, or basically the temperature without greenhouse effect, is approximately 279 Kelvin. But the actual temperature is a little bit higher at 287 Kelvin. But if you compare this to Venus, it's way more extreme. 328 Kelvin equilibrium, or basically if there was no atmosphere, or 730 Kelvin surface temperature because of Venusian atmosphere that creates an enormous greenhouse effect. But interestingly, this planet is somewhere in the middle. It's about 15 Kelvin lower than Venus and about 30 Kelvin higher than Earth. And even its size is a little bit smaller than Earth and a little bit bigger than Venus. And so here we have this very intriguing world, and as you can see in this image, it's presented in 3 different types, because we actually have no idea what the surface might be like. It could have no atmosphere, a little bit of atmosphere like Earth, or atmosphere like Venus. which would very likely dramatically change what's happening on the surface. For example, obviously, with no atmosphere, it might resemble something like, I guess, Mars. A dry, empty world that goes through some extreme changes between the day and the night. But with a slightly thicker atmosphere, similar to Earth, here the temperatures might be a little bit higher, possibly as high as 60 degrees Celsius on the surface, which would make this a somewhat difficult world to survive on. But this planet is also very likely tidally locked, and so it would have certain locations that would be a lot more hospitable. Lastly, with the Venusian runaway greenhouse effect-like atmosphere, or basically a very thick atmosphere, temperatures here would be pretty hot, possibly hundreds of Celsius, with extremely dry conditions, and very likely something similar to what's happening on Venus. And so here we have these three options. Or maybe there's a fourth option that we cannot think of yet, because this is obviously a completely different star system. I mean, for one, maybe this planet contains a sulfur-rich atmosphere and is thus actually cooler, bringing its temperatures much closer to planet Earth. Either way though, this discovery is currently super exciting. It's essentially the closest transiting Earth-like exoplanet that's now officially the best potential target for the James Webb Space Telescope to start looking for habitable conditions on exoplanets. And this is even a better planet to look at than the TRAPPIST-1 planets or the very close to us Proxima b. And that's because this planet is not transiting. The only way we can actually detect atmospheres and find out what these planets are like is, of course, if these planets form a shadow in front of a star. This planet does, Proxima b doesn't. And by itself, this is a huge discovery, because by focusing on the light that passes through the very thin layer of the atmosphere right here, the researchers can find out everything there is to find out about this planet. At least in terms of what's actually on the surface, what kind of a light is reflected from the surface, what the atmosphere is made out of, and then start making conclusions about, is this habitable, is there maybe life here, and even start using statistics in order to find out if this applies to the majority of M-type stars in the Milky Way galaxy. Because if there is something going on here, it's extremely likely that this is actually a very common phenomenon. In other words, by exploring what's happening on this planet, we can start drawing conclusions about a much wider sample of various planets discovered in the last few decades around many red dwarfs. And so out of thousands of planets discovered around various star systems out there, this one actually right now is one of the most exciting ones. With this planet discovered using the NASA's TESS space telescope, along with the Muscat 2 and Muscat 3 cameras, they're a part of the Subaru telescope run by the Japanese astronomers. But because this is a very recent discovery, there's unfortunately not much else we know. We actually don't even know the mass of this planet. It just seems to be much less massive than about 3.9 masses of planet Earth, but that doesn't tell us much. So even the mass here has not been measured yet. And that's because to measure the mass, the researchers have to use the radial velocity method you see right here, where we observe the star being pulled by the planet through observations of redshifts and blueshifts. This hasn't been done yet, so the mass is unknown. But because its orbital period is 12.8 days, we know that this is in the habitable zone. That's the usual period for planets orbiting red dwarfs in habitable zones. But only time will tell if this is going to end up some kind of a super exciting planet, or just another planet like TRAPPIST-1b and TRAPPIST-1c that seem to be completely barren. Okay, today we have some bad news for Trekkies. Vulcan, the home planet of Mr. Spock right here, might no longer exist. And not because it was destroyed, like in the 2009 version of Star Trek, where a Romulan villain named Nero creates an artificial black hole, destroying Vulcan once and for all, but instead it seems to not exist for scientific reasons. And so, hello wonderful person, live long and prosper, wonderful person. Today we're going to discuss Vulcan, the real Vulcan, talk a little bit more about the science behind this, and talk about why it's no longer there. And here I think we have to start with this. This is a system known as 40 Eridani. It's a triple star system approximately 16 light years away from planet Earth, and it's a somewhat exciting system for different reasons. And it just so happens that according to the Star Trek canon, 40 Eridani A, the main star here, possesses a planet named Vulcan. And this is something that was hinted in the TV show many times. But the first appearance was in this particular episode back in 1967. This was the first episode of Season 2. And so back then, Vulcan was described as a really hot planet with a relatively thin atmosphere but also really high gravity, roughly around 1.4 times higher than planet Earth, and it was at a distance of 16 light years from the solar system. And though in Star Trek it's never really explicitly called 40 Eridani, as in the actual name never comes up, just based on the distance alone, this is the only star system that matches. And it's technically later confirmed in various additional books and even by the producers themselves. And so in other words, this is a real star system, and actually a star system that you can see with the naked eye because it is pretty bright. Here the main star is what's known as a K-type, somewhat similar to our Sun, but just a little bit less massive and also a little bit cooler. But it also possesses two partners. One of them, at a distance of 400 astronomical units, is a very typical red dwarf, or basically an M-type star, although in this case it's also referred to as the flare star. And that's because these types of stars produce a lot of powerful X-ray flares. And as we know from a lot of other star systems, these types of flares can easily strip atmosphere from pretty much most planets really quickly. But then it also has a partner that's a white dwarf, and millions of years ago this used to be the main star. It was much more massive before, until one day it formed a planetary nebula, expelled a lot of mass from the system, and basically became this white dwarf. Interestingly enough, this is the first white dwarf we've ever discovered. It was discovered back in 1910, and it was very strange because it was extremely white. And it actually took many decades to finally figure out what this was. And so even though this is not the closest white dwarf to us, it's technically one of the few white dwarfs out there that you could easily see with a telescope, and more importantly, it's the brightest white dwarf in the night skies, despite other ones being a little bit closer. And for example, Sirius B, which is much closer, is impossible to see because it's too close to the partner star. But here the distance is about 40 astronomical units away from the partner, so it's much easier to tell them apart. But this also means that it's really only the main star, 40 Eridani A, that's technically exciting for any kind of a planetary discovery. And for this particular star, if it does have some kind of a habitable planet, it would most likely be orbiting every 220 Earth days. But no such planet seems to exist according to most recent studies, or basically there seems to be no habitable planet based on most recent observations. However, something was discovered in 2018. You can read about this in the study you can find in the description, but in essence by using the method known as the radial velocity method, or basically the method where we kind of look for the star to wobble because something is in orbit around it, the scientists discovered that this star seems to change every 42 days. Or basically it seemed to contain a somewhat predictable 40-day period, implying that maybe there was something in orbit and that something was kind of massive. Not like Jupiter massive, but more like 8.5 masses of planet Earth massive, suggesting some kind of a hot super Earth or maybe mini Neptune. And if this was some kind of a super Earth, it would very likely have higher gravity, possibly up to 1.5 times higher than planet Earth, and would obviously be somewhat hot. And surprisingly, this was almost a direct description for planet Vulcan from Star Trek. And so back in 2018, this was actually kind of interesting, mostly for Trekkies, because maybe this was the scientific information that Vulcan actually really exists, obviously in terms of the planet, not the aliens. Although naturally here it would be way more extreme and extremely unlikely to possess any conditions for organic life. And so because of these radial velocity transitions, and because I guess this was kind of unusual, because it matched the planet from Star Trek, a lot of scientists try to see if this is really there, or if there's something else going on here, and we're just basically being silly, and this is all just wishful thinking. And basically it took approximately 5 years to start discovering what's possibly happening here. With this paper, the one that was just released a few weeks ago, basically presenting the final conclusion, the death of Vulcan. And in a nutshell, it once again focuses on a very similar technique involving transit velocity, although here the researchers used a new NASA instrument on top of the Kitt Peak Observatory in Arizona that contains a new instrument able to conduct extremely accurate transit velocity calculations by once again using the Doppler effects. Or just to rephrase this, it uses the red shifts and the blue shifts of the starlight to try to find any kind of a periodicity that could be caused by a hidden object, such as a planet. And once again, they did discover something going on here. But the results were a little bit different, way more unpredictable, with the period changing between 38 and 45 days. And that by itself was somewhat unusual because it basically suggested that this could not be an orbiting planet. And this was probably something caused by the rotation of the star itself. As a matter of fact, because we know stars rotate and usually have a relatively constant rotation period, we can usually determine this by observing certain features on the surface of a star, for example, some kind of a sunspot. And so here, by revealing individual differences in several different wavelengths, they basically realized that all of this is probably caused by some kind of a flicker on the surface of the star. Something that coincides with the 42-day rotation, and something that's probably caused by various layers inside the star. So possibly just the result of convection under the surface. And that's because normally, if this was a planet, the periods would be a lot more constant and a lot more predictable, producing a very different observation. And so basically here, what we're observing is extremely likely stellar activity and not a planet, not Vulcan. Which implies that the planet is technically not there. Or if you want to be Trekkie about it, I guess it was destroyed after all by that evil Nero who destroyed the planet with an artificial black hole. But in terms of science, this is actually kind of important because these new methods established extreme accuracy. Which means that these methods can now be used to actually find planets around other star systems or confirm the existence of additional planets that the researchers were previously not so certain about. For example, the nearby system of Proxima b potentially contains additional planets, and so this new method could definitely confirm or disprove their existence. And so these new techniques for radial velocity method are super important. But I guess it still doesn't change the fact that one of the most iconic science fiction planets out there, planet Vulcan, seems to be fictional after all, even though the previous paper kind of gave us just a little bit of hope. Okay, but maybe some of these other ones are real. So what's next on the list? Oh, how about Krypton? Maybe that's real. But anyway, at least for now, that's basically all I wanted to mention. Unfortunately, there's no planet Vulcan orbiting Eridani A. But once something else is discovered around the star system, we'll come back and talk more about this in some of the future videos. Until then, live long and prosper, even though technically your planet no longer exists. So it's now been almost 2 years since James Webb started doing science. And during these 2 years, he was able to prove to us how incredible it is at being able to see things we could never see before. For example, exoplanetary atmospheres. Discovering if certain planets have any atmosphere at all, and basically clarifying certain things about certain planets. And in one of the previous videos that should be in the description, it already revealed certain things about the famous TRAPPIST-1 system, probably the most exciting exoplanetary system we know, but pretty much every month now we get a new study about some kind of a planet where someone discovered something. For example, methane has now been discovered around several planets, including WSP-80b. And this is of course something that we do expect around various ice giants, which of course makes this a somewhat intriguing confirmation. It means that ice giants are generally kind of similar in a lot of star systems. Here we're talking about planets like Neptune and Uranus. Likewise, by analyzing the atmosphere of WSP-17b, a hot Jupiter really far away from us, 1300 light years, it was able to discover unusual crystal clouds made out of quartz. Not something we actually see pretty much anywhere, but that's essentially how good the telescope is at finding these minute elements. Then it was able to discover silicate clouds, water vapor, sulfur dioxide, and no methane around WSP-107b. Another really hot planet, but once again with very exotic atmosphere we've never seen before. And in this case, the actual observations are very detailed and provide us with a lot of evidence, but also help us understand how a lot of these exoplanets are just so different from anything in the solar system. There was even a confirmation of unusual clouds around WSP-107b that seems to contain water vapor and sulfur dioxide clouds that form on the night side of this somewhat hot planet. But so far, pretty much all of these planets were basically different forms of gas giants. Planets with very extensive atmospheres, but not really planets that are super exciting for example, finding life. But now we have a very recent study that basically once again kinda went viral because of the star system that's explored and of course the discoveries. This is a star system known as 55 Cancri, an intriguing binary system where we know at least 5 planets seem to exist, and a system that's approximately 41 light years away from the Sun. The system is actually really famous and it even has a proper name. The main star here is known as Copernicus. But the star also has a partner, a smaller red dwarf. But today we know that it has at least 5 planets, named after various astronomers. And though most of them seem to be really massive, very likely once again gas giants, the closest planet, planet Cancri E, also known as planet Janssen, is a little bit different. Even though it's approximately 8 masses of planet Earth, it's extremely likely to be terrestrial in nature. But also, as you can see from these simulations by NASA, potentially some kind of a really hot lava world. Now that by itself is debatable, but we know that because of its proximity to the star, which is actually just a little bit less massive than the Sun, this is a K-type star, the temperatures here are definitely very hot. The day-side temperature is over 1700 Celsius, 3100 Fahrenheit, or basically hot enough to melt iron, with the night temperature possibly being a little bit cooler at maybe 1100 Celsius, 2000 Fahrenheit. And because this planet is tidally locked, it does have very different temperatures, as recently confirmed by James Webb. And this planet has been known for at least 20 years. It's actually one of the first terrestrial exoplanets ever discovered. As a matter of fact, when it was discovered, it was so exciting that some scientists even decided to send a kind of an extraterrestrial message to this star system. It was part of the project known as Cosmic Call that was actually conducted in Ukraine. This is part of the principle known as METI that you can learn more about in one of the videos in the description. And so in theory, this planet is going to be receiving these signals in 2044. But that's obviously beside the point. The point is that this planet was super exciting because it was terrestrial and it was orbiting a sun-like star. But still very different from anything in the solar system, way more massive than Earth and much closer to the star. Fun fact, the star system here is so bright that you can technically see it with the naked eye. And so if you do actually have some kind of a telescope, in theory, you could even observe the motion of this planet around the star. You will see it as tiny dips approximately every 17 hours. And this is also a relatively old star system, possibly up to 10 billion years old. So these are not new planets, and are thus particularly interesting when studying atmospheres. Mostly because scientists want to find out how these atmospheres can survive or change over time, especially as star systems evolve. And while initially, in 2016, the observations by the Hubble Space Telescope revealed potential detection of hydrogen and helium, but definitely no water vapor at all. With additional observations even suggesting that this could be what's known as a carbon planet, or basically a planet enriched in carbon instead of oxygen like Earth. Here it was even suggested that because this planet was possibly mostly carbon, it might even have some kind of a diamond core on the inside, or at least have mantle in strange and unusual diamond-like formations. But all of these discoveries and analysis was more or less preliminary, until of course now, because the James Webb finally revealed something else, providing us with the best evidence we have so far for an existence of very interesting atmosphere around a rocky planet, obviously outside of the solar system, and specifically atmosphere containing volatiles, not really hydrogen or helium as expected from gas giants, and not things like iron or silicate expected from super hot planets where things are just more extreme. Instead, here it was something else. And the way it was discovered is of course really cool. Here once again the researchers were basically looking at how this planet seems to change as it orbits the star. Specifically, they were observing changes in brightness as it moved around the star and then as it moved in front of the star or behind the star. And by then subtracting the brightness during these secondary eclipses, they were able to calculate very specific wavelengths of infrared light coming from the day side and the night side of the planet, which is actually seen in this graph. And then they compared this to various models. For example, models involving some kind of a rocky atmosphere, such as silicate atmosphere, or a model involving a planet rich in volatiles, maybe carbon dioxide or carbon monoxide. And so here one of the main discoveries was basically a large difference between the day side and the night side temperatures, which actually suggests only one thing: an extremely effective way for this planet to somehow distribute energy from the day to night sides. And if this was some kind of a lava planet like you see in the simulation here and essentially contained nothing else, or for example maybe no atmosphere, it would just not have enough ability to transfer all of this heat from one side to the other. So this is kind of out. Instead, it seems to definitely contain some kind of a volatile, for example carbon dioxide, something to absorb some of the heat and to then transfer it somewhere else. And here the researchers actually see an unusual dip at 4 to 5 microns. This is something that's usually seen only with volatile atmospheres. Now nobody's actually sure what exactly this is, but this is definitely an atmosphere potentially similar to what we detect on Venus or Earth, although probably more Venus than Earth. But this also obviously raises the next question. How exactly does this work? Where is it coming from? And why is it still there? Once again, these are ancient planets, possibly up to 10 billion years old, which means that over time, as you see in this simulation, this planet should have already lost all of its atmosphere a long time ago, especially if the atmosphere is volatile, yet somehow it hasn't, which now suggests that this is possibly a secondary atmosphere, or basically something inside the planet is constantly replenishing the atmosphere, releasing it very likely from within the mantle, and here they think it's maybe, possibly, related to magma. And so one explanation is once again some kind of a magma or lava ocean that releases a lot of carbon dioxide and possibly some other gases, but in such huge amounts that it forms a relatively thick atmosphere around the planet, which is then constantly replenished at all times, with the mechanism basically involving the mantle of the planet slowly releasing all of these gas deposits from within, in some sense similar to what happened to Venus and of course what's happening on Earth. And since here we can kind of tell that this is a sustainable mechanism that possibly existed for billions of years, in some sense when it comes to exoplanets and potential discovery of habitable exoplanets, this is definitely a really important discovery. It confirms that atmospheres can actually exist for a very long time, can be created again by various planets depending on the conditions, and most importantly, can contain volatiles similar to planet Earth. But obviously, at least for now, that's really all we know. But what's really important is that these techniques are getting better and better, and so it's very likely that in the next year or so, we're finally going to hear about an actual terrestrial planet, possibly in a habitable zone, that also has some kind of a really intriguing atmosphere. And that's because, as this technique shows here, by studying these secondary eclipses, the researchers can definitely figure out what these planets are covered with. And so it's only a matter of time before we actually do find a planet possibly containing conditions not so different from some of the terrestrial planets in the solar system. And I guess if we look hard enough, we might even find something similar to planet Earth. Now obviously finding habitable planets and the ones with life on them is still going to be really challenging and will definitely require years of confirmation, but I'm sure in the next year we're going to hear about some other exciting discoveries that will basically blow everyone's minds. In the last few years, there's been way too many discoveries when it comes to exoplanets. Too many to cover every day, mostly because of prolific telescopes like the NASA's TESS. And TESS stands for Transiting Exoplanet Survey Satellite that was basically supposed to replace Kepler, and replace it did, already discovering over 7,000 potential planets, or basically almost double of what Kepler discovered. And that's since its launch in 2018, but it still has so much to go. But obviously in these last 6 years, it did make some really strange discoveries, or discoveries that basically nobody expected, with some planets being super exciting. We've discussed some of them in some of the previous videos in the description, but today we're going to be discussing the most recent discovery that represents something we've actually never seen before, but also something super exciting, and as always, in the habitable zone of the star system, the zone where we can actually expect liquid water to exist. And so, hello wonderful person, this is Anton. Let's talk about this new unusual exoplanet, why it's kind of exciting and somewhat strange, and of course talk about what this discovery means. But first, a quick reminder on how TESS searches for planets, and of course how this planet was discovered as well. This is the famous transit method, the method of looking at the star for a really long time in order to discover periodic dims in brightness. But depending on the type of a dim and also depending on its length, we can actually use this to determine quite a lot about what passed in front of the star. As a matter of fact, by using the length and the depth of the dip, we can pretty much determine the exact size of the planet, and if there are any other objects in the vicinity, we can even work out its mass. And so by knowing the size and the mass, we can then start making conclusions about what sort of a planet this is, and how it compares to the solar system. And so in the last decade, a lot of super exciting exoplanets have been discovered this way. I guess the most exciting is still the TRAPPIST-1 system, but the one we're discussing today is exciting for slightly different reasons. So first, the study about this is as always in the description below, but here it's actually really important to mention that it wasn't really the scientists that kind of discovered this. It was the volunteer citizen scientists, part of the very famous Zooniverse project. This is a volunteering project that basically uses thousands of different participants, which you can actually become yourself. The link about this is in the description if you want to learn more. But basically by combining discoveries from the citizen scientists with the analysis of astronomers behind the study, they were able to discover a system that was initially missed by previous studies. Here they discovered an unusual, potentially Neptune-like world passing in front of a star extremely similar to our Sun. It's a G-type star. But here at first it only passed once, and the second passage was 272 days later, making this basically the second longest period discovered by TESS so far. And by having a planet in such a long period around a G-type star, it basically places it in the habitable zone, the area around the star where we can kind of maybe expect liquid water. But by continuously looking at the star system, they started to discover more things. First they found potentially a second planet, much closer with a 34-day orbit, but also much bigger. Here this was potentially some kind of a Jupiter-like planet, or possibly a little bit more similar to Saturn because it's just over 100 masses of planet Earth. But because it orbits much closer, at a distance of Mercury from the Sun, it would naturally be much hotter. So this is basically a hot Jupiter. But so far this is not too surprising. We've seen such star systems before, and even finding a habitable planet with a hot Jupiter is not really that big of a deal, at least anymore. A few dozen similar star systems exist out there, but it's really the third discovery that kind of surprised everyone. And for this they had to look at the star using archival data from basically up to 100 years ago. And so by looking at 119 years of various observations, they actually discovered that this is not a single star, it's a binary system. And the second star orbits in a very strange way. Very eccentric orbit that actually takes it really far away from the main star for at least 230 years. But strangely enough, every 231 years, that star returns and approaches the star system at approximately 4.5 astronomical units, just a little bit closer than Jupiter to the Sun. And currently that second star is actually pretty close to the first star, basically in the inner star system, which is why they kind of resemble a single object. But in older data, when they're much farther apart, it becomes obvious that this is a binary system, making this a very unique star system we've actually never seen before. So we have this unusual Neptune-like planet, potentially 47 masses of planet Earth, and approximately 3.2 times size of planet Earth, but also in a habitable zone, which is super exciting. And that star system also has a second star that actually comes pretty close to everything every 231 years, potentially creating some really strange weather cycles around the star system. Here's actually an animation showing us what all of this might look like from just above the cloud layer of this planet. But I guess what's even more exciting is that previous studies have also suggested that a lot of these long period planets will usually contain a lot of moons, kind of like Jupiter, Saturn, Neptune and Uranus. And because here the period is 272 days, a chance for this planet to have a lot of moons is also really high. And it's of course the moons of this particular planet that would be especially exciting, mostly because we expect these moons to be kind of similar to what we have in the solar system, and thus potentially have liquid oceans. Since they are in a habitable zone, and since these moons would be predominantly a mixture of rock and likely a lot of water, they do have a chance to basically just be these global ocean worlds, possibly even with some kind of an atmospheric layer. And on the planet itself, which is currently referred to as Percival, named after a character from Harry Potter, is unlikely to be too exciting in terms of habitability, even though it potentially contains really warm or maybe even hot water clouds. It's really its hypothetical moons that the scientists are kind of excited to discover. And that's because statistically, some of them are going to have solid surface, some of them are going to have oceans, and some of them might even be kind of like planet Earth, just a little bit smaller in size. And so here the researchers are basically hoping for a new campaign, possibly with James Webb Space Telescope, especially because the brightness of the system is perfect for detecting these worlds. This is actually the brightest star currently known to us to host an exoplanet in the habitable zone, with the star itself being very similar to our Sun. Although here, because of the planets discovered so far, this can also help scientists figure out how planets form around binary systems, because this is also a very unique binary. And normally, when it comes to binary star systems, we actually don't find planets around them very often. And so here, this is a chance for scientists to figure out how planets form around multi-star systems. Here's roughly how the stars and the planets compare in terms of size. And it's that planet C that we're really curious about. But once again, all of this a result of citizen science, with this project involving over 43,000 members, already helping catalog approximately 25 million different objects. Not all planets, actually quite a lot of different objects, including asteroids, but this is basically one of the reasons why so many incredible discoveries have been made in the last 10 years. A combination of citizen science, working alongside with professional astronomers, and sometimes just a little bit of artificial intelligence. But even according to astronomers here, AI is just not really good at this compared to actual humans. And so if you actually have any interest in astronomy, consider joining in one of the links in the description. But when it comes to this bizarre star system, unfortunately we're not going to know much more about it until future observations or until the stars separate a little bit more in the next 30 years. It's right now still difficult to study all of this, because basically the stars are just a little bit too close together. Nevertheless, right now this is probably our best chance to potentially discover some kind of a habitable exomoon. Moon containing conditions perfect for extraterrestrial life. A few months back, there was an unusual discovery coming out of James Webb Space Telescope in regards to this planet you see right here. This is a simulation of K2-18b, a very intriguing exoplanet that might be in the habitable zone of the star system it's in. A star system that we know contains another planet, but that one is much closer and thus much hotter. But the reason this particular planet was suddenly in the news and everybody was talking about it was because of this. The most recent observations of the atmospheric composition that revealed something really strange. First of all, a lot of methane. And as you might be aware, methane, in theory, could be a biosignature, or essentially a sign of potential life. Now, it doesn't have to be, but there is always a chance. There was also an abundance of CO2 or carbon dioxide and a complete lack of carbon monoxide, which is not so different from what we would find in the atmosphere of planet Earth. But much more interestingly was a potential detection of this, DMS or dimethyl sulfide, a toxic gas that here on planet Earth we know is only produced by life. It's not natural in any way, and it's only produced by certain algae in the oceans, and so basically, if this was real, it was maybe a direct detection of life on another planet. You can obviously learn about all of this in one of the previous videos in the description. But here's the thing, and I guess it's a really big thing. All of this was super hypothetical, and obviously quite a lot of scientists kind of questioned the analysis here, with many additional papers coming out afterwards, and a lot of them discovered additional things we didn't know about before. And so, hello wonderful person, this is Anton. Let's discuss these follow-ups in regards to K2-18b, talk about what's most likely happening here, and discuss some of the new studies that actually do present us with new options. But I guess first let's briefly discuss some of the important details, including why methane is kind of interesting to begin with, and also what sort of a planet scientists believe this to be. And so following these initial studies, one of the first propositions was that this was the first confirmed Hycean world. In essence, a very unusual planet containing an enormous ocean, and actually ocean containing liquid water, whose name is formed by two different words, hydrogen and ocean. Because in this case, not only does it have a very large ocean, and possibly just ocean, it also has a really thick hydrogen atmosphere. The atmosphere that would leave this planet with very hot temperatures and thus produce a kind of a supercritical water, or at least water that's just a little bit warmer than what we're used to. And so a lot of density data coming from this planet imply that K2-18b could be something between a super-Earth and a sub-Neptune, and thus sort of fit the description for a Hycean world. And since the average temperature of equilibrium is a little bit lower than what we have on Earth, the chances of this planet to have liquid water was somewhat high. And so these detections of methane were kind of super exciting, especially because methane generally does not actually last in the atmosphere for longer than 2 or 3 years. Normally, because of the solar radiation, it completely falls apart, and so something definitely has to replenish it in some way. But the question is that something life? And here we have to be very careful. Here's actually one recent story coming from Mars, with a video in the description talking about this a little bit more. For many years, scientists have been detecting unusual detections of methane that seem to be very periodic and happen during certain seasons on Mars, with a lot of scientists assuming that maybe this was a sign of bacteria living here, releasing this methane when things get a little bit more comfortable. Something similar is actually even seen on objects like Titan orbiting Saturn. But a much more recent analysis directly established that this is indeed a geological process requiring no life. And it's really a result of a seasonal change that affects certain rocks that then suddenly release more methane. You can once again learn about this in that video. And so methane by itself can be produced in so many different inorganic ways. And so for terrestrial planets like Mars, serpentization is one of the biggest ones. It usually involves all kinds of rocks. And since methane has actually been found on all of the planets in the solar system, and its existence has been explained without the use of any life, except for Earth of course, in this case, detection of methane can also be obviously produced through natural means. And so this planet could also have some kind of an active source that we're just not familiar with. But then there was also CO2, and so together, these two molecules could maybe serve as a sign of potential life. And actually, statistically speaking, methane could be biogenic for planets that are normally much older, terrestrial in nature, containing additional molecules such as CO2. But the question is, of course, could this planet be terrestrial? Right now, this wasn't really clear. And the other question was DMS, or that dimethyl sulfide. The 2023 detection was not really a detection as much as it was just a hint. As we've discussed in that previous video, here the detection value was extremely low and practically insignificant, and so the fact that the authors even mentioned it was maybe just for attention, to be honest. It didn't really make sense. And so most scientists kind of ignored DMS as even being in the atmosphere. It could actually have been something entirely different. Kind of similar to what happened with Venus and the phosphine detection, which turned out to be maybe not a detection. But anyway, a much more important study, and I guess a much more important detection, comes from something else from a few months ago in regards to a different planet. A planet that you see right here known as WASP-80b. Here, extremely recently, using very similar observations, methane was also discovered in pretty much the same amounts. And that's of course something that is expected. But this planet is a gas giant, as you can see right here, yet it's orbiting a very similar type of a star as in K2-18b system, with even very similar age. But intriguingly here, there was also a clear evidence of not just methane, but also once again water. Yet it's not a rocky planet, so methane cannot be explained with things like serpentinization, and water can probably not be explained with an ocean. Yet everything else about this planet, in terms of detections, was extremely similar to what we just saw on K2-18b. Okay, no DMS, no dimethyl sulfide, but definitely water, definitely methane. Which actually led to more discoveries about K2-18b as well. Now, just as a reminder, this is not an Earth-like planet. This is maybe a super-Earth, or maybe a mini-Neptune. It's about 8.6 masses of planet Earth, and it's also a little bit larger. But, unlike on the other planet, here the water was not visible in the atmosphere, it was just implied to exist on the surface. So I guess that's basically one of the main differences. But that's also the important part. A lot of this was kind of implied and suggested, none of this was definitive, and none of this explained everything all at once. And so the overall evidence for everything but carbon dioxide and methane was really weak. Yet the conclusion was that this planet was not just possibly habitable and potentially containing an ocean, but that it was also inhabited by something producing CO2, methane, and DMS. And that was honestly quite a big jump, which is why a lot of scientists kind of decided to maybe see if they can disprove this or provide additional explanations. And there were quite a lot. A lot of things can explain everything we observe here, and none of them involve life or even a terrestrial planet. With one of the studies even providing evidence that you can actually explain all of this if this is a lava planet. Everything we observe could be produced by pure lava. But that's not the one I wanted to discuss. I wanted to discuss a much more interesting study, and actually a study by a NASA team that was able to produce extremely accurate simulations comparing several different scenarios with the direct observations from the James Webb. And in this case, their models predict the planet's photochemistry, or essentially various chemical reactions, that are usually driven by photons from the star itself, something that is kind of visible in the data from the James Webb. And here, of all of the different scenarios, I guess two were maybe most exciting. In one of the scenarios, they imagined this to be a real high-ocean world with basically no life. And so in essence, you have that superheated ocean, or very hot ocean, and a lot of hydrogen in the atmosphere. And turns out that it's not a match. This is unlikely to be a lifeless water world, mostly because it would not contain enough methane. Yet, interestingly, if you do add certain bacteria, such as these little guys, often known as acetotrophic methanotrophs, or basically bacteria producing methane and surviving through different chemical reactions, suddenly things looked a little bit better. It was not a 100% match, but it definitely looked slightly more accurate. Here's once again what it kind of looks like. But the best model was not this at all. The biggest match was a mini Neptune, or basically a planet containing no oceans, no terrestrial surface, and instead being an uninhabitable, gas-rich, Neptune-like planet that would have a very high methane concentration because of an upwards mixing of gases from inside the planet. Due to greenhouse gases, this would be way too hot for most life to survive. And by itself, it is a slightly, I guess, easier explanation. So here we have that Occam's razor, but also an explanation that does not require anything else in there, because we know planets like this do exist. As a matter of fact, we know there's a lot of methane on both Uranus and Neptune, and they do provide somewhat similar observations. And so does that mean that no life? This is just another gas giant? Well, not necessarily. None of these models were super 100% accurate. There was still something missing in all of them. And so there's still maybe a chance that there could be life and this planet could be inhabited and that it could be a water world after all. That explanation is still not cancelled completely. And so more observations from the James Webb will be definitely required to confirm or disprove all of this, especially observations in different frequencies in order to really see what's going on in the atmosphere. But at the moment, it's really looking more and more like maybe this is not a water world, not even a high-ocean planet, and maybe not even a planet containing anything super exciting. Maybe this is actually just a gas giant, just like so many other ones we've seen before. In order to discover exciting exoplanets, and in order to understand what's happening on them, today most scientists try to focus on studying atmospheres. Because obviously the atmosphere is crucial for potential life or habitability. But since many of these planets are super far away, currently there are not a lot of techniques we can use to try to understand what's happening here. The most common way involves the star, and specifically the starlight, passing through the atmosphere and absorbing certain frequencies due to the atoms in the atmosphere, but this just tells us about what's here, not how much and not what it does. Yet in the last decade, the scientists started to discover more techniques, with some even focusing on what we see on Venus and then trying to interpret this as something that could be happening in a different star system. And interestingly, just over a decade ago, back in 2011, for the first time ever, the researchers detected a phenomenon that's only been previously seen on planet Earth. Now, it's a little bit difficult to see it here, but in essence, it's a phenomenon that looks like this on Earth. It's known as a glory. And so a very similar phenomenon was discovered on Venus, that's visible here on the left, compared to the phenomenon from Earth on the right. Although in this case this is not an actual image, this is a simulation, to highlight how they're not exactly the same. The actual image is right here, although this is actually visible only in the UV light. And so in essence, glories are kind of similar to, I guess, rainbows. It consists of a lot of concentric, successfully dimmer rings with different colors. On Earth it's usually red on the outside and blue toward the center, but it's obviously going to be different on Venus. But this is not a rainbow. A rainbow usually forms when the sunlight passes through some kind of a medium that has certain density, but it goes into a different medium with different density, thus creating a refraction similar to a lens. In most cases on Earth this is air to water. In contrast, a typical glory seems to form when the light passes between extremely tiny droplets in, for example, clouds or fog, with the light in this case experiencing diffraction and not refraction, as what you essentially see right here when we have two tiny holes forming a diffraction pattern. So it's a slightly different effect, but does seem to produce somewhat similar observations. And so approximately a decade ago, this phenomenon was discovered on Venus. And that meant one thing. It meant that there is something in the atmosphere on Venus that's able to do this just like on Earth. And though for us on Earth, it's obviously once again water droplets, something else on Venus was diffracting the light, producing these interference patterns, which actually can also be imagined this way. This one is made with a laser, but in this case the laser light is passing through a tiny hole, forming a ring-like diffraction. And so it turned out to be most likely sulfuric acid. Tiny droplets of sulfuric acid were forming this on Venus as well. But because they're different in size compared to water on Earth, approximately 1.2 micrometers across, they were obviously producing slightly different effects. But most importantly, they had to be uniform in size and they had to be in a large enough volume of space, which is how this was visible. It kind of suggests that on Venus, sulfuric acid droplets seem to basically create similar effects to water droplets on Earth. And these particles always have to be spherical, relatively small, and liquid. So tiny droplets, but in this case, acid, not water. But that was over 12 years ago. Now we have something a little bit more exciting from a much farther away and a much stranger planet. Actually, a pretty well-known exoplanet, WSP-76b, discovered in 2013. And this planet is pretty extreme. It orbits its star every 1.8 days, and as a result is extremely hot. 1900 Celsius, 3400 Fahrenheit. Although that's average, the day side is much hotter. But because it's so close to its star and because it's been investigated for so many years, we do have a lot of data about its composition and its overall atmosphere. For example, there seems to be evidence of titanium oxide and even small amounts of water, as well as lithium, sodium, magnesium, calcium, manganese, potassium, and iron, with all of this very likely just being in the atmosphere as a kind of a vapor. It was also that one planet where the researchers suggested that it probably has some kind of an iron rain, and this might even happen right in the twilight area, or basically right here between the hot side and the slightly cooler side, where the droplets of iron start to condense and turn into liquid, forming a kind of an iron rain that lands on the surface. And that's because the temperature between the day side and the night side is extremely similar to the condensation temperature of iron. And so despite this planet being 640 light years away from us, all of this was quite definitive and visible with modern telescopes, and that by itself is really impressive. But these discoveries were from years ago. Now we have something new. As you might have guessed by now, by looking at this planet again and looking at new data, the researchers noticed an unusual excess in brightness in one of these twilight areas. Specifically, this one is known as the Eastern Terminator, the boundary between the day and the night sides. Now this planet is tidally locked, so basically one side is always facing the star and the other side is always in the darkness, so this area doesn't move much, but it does have very unique effects. One obviously being that iron rain, but another one seems to be that glory. The strange increase in brightness that was actually symmetrical resembles something similar observed from Venus back in 2011. And previously this has only been seen on Earth and on Venus, not any other planet. But once again, this does require droplets, spherical droplets of the same size and resembling a liquid. And so on such a hot planet, it possibly confirms that this is iron, and these are iron droplets, and they also have to be inside the clouds and be constantly replenished by something. In other words, just like on Venus and on Earth, it suggests a relatively permanent atmospheric conditions, although in this case obviously super hot, but at the same time, the actual element is currently unknown. It could be something entirely different, and it could actually be a liquid we've never seen before, as in it could be some kind of a unusual alloy that becomes an aerosol in these extremely hot conditions. But since in this case glory can only be formed by relatively constant conditions, which means at least a couple of years of replenishment in the atmosphere, it of course implies that the atmospheric conditions here seem to be pretty permanent, basically confirming that some of these extreme planets can still maintain extreme conditions inside their atmospheres, even if that means that there are thousands of degrees in temperature. But because this is a hot Jupiter, or basically a planet that's very similar to Jupiter, but just much hotter, it is a much more exotic planet compared to some of the other planets researchers want to study. So obviously not a terrestrial world and not even a super Earth. Nevertheless, by finding glory here and by knowing what to look for, we can now find ways to look for similar effects around other planets as well. And more importantly, we can even use other visual features and visual effects to possibly even start discovering minute reflections from various oceans and lakes that could also produce glory effects from certain angles. And that by itself is what's exciting here. By knowing that this exists and by knowing what to look for, this can now be applied to other planets, including planets in the, for example, TRAPPIST-1 system, or the much closer Proxima b, that's also in the habitable zone. And so if we find something similar here, now that's going to be super exciting. And that would suddenly give these planets a much higher chance to potentially host life. Once again, these glory effects only form when there are permanent clouds that are able to create these perfectly spherical droplets that have to last for at least a couple of years. And more importantly, usually they imply constant temperatures and constant pressures, which is of course why both of these are visible on both Venus and Earth, two relatively different terrestrial planets with relatively stable atmospheres. And so in the next few years, researchers might finally have different ways to look for these unique visual phenomena that can actually indicate something super exciting on surfaces of exoplanets, different types of water, permanent atmospheres, and maybe a chance of life. And that actually might be the next focus for a lot of exoplanetary studies, trying to identify various optical phenomena that we know from planet Earth and we've observed on planets like Venus and possibly even Mars that has a very thin atmosphere. Many have been detected in the last few years, with many caused by different things. And since we can't actually identify tiny lakes or even large oceans on these planets, the only way we can see them is if they basically somehow interact with the starlight by reflecting it in a certain way. And so we're maybe entering a new era of discoveries on various exoplanets. And so honestly, I can't wait until we see some kind of a distant reflection from an exoplanetary ocean. So what if a lot of planets that might host life out there don't actually look like planet Earth at all, but instead look like this? What if they're all unusual ice worlds with a very large ocean underneath that has plenty of life to go around? And what if we actually have a way to prove all of this by looking right here in the solar system? And so, hello wonderful person, this is Anton. Today we're going to discuss a relatively recent study that makes a very intriguing proposition that there could be 17 known exoplanets out there, not so far away from us, that could be extremely similar to something we have right here in the solar system, which are of course ice moons. Moons like Enceladus. And they might have extremely similar effects to Enceladus, with extremely large oceans underneath the shelf of ice that protects all of the life living on the inside. And so let's discuss this in a little bit more detail, but let's actually start with a lot of discussion about Enceladus in the last few months. And here I wanted to start with the webpage you can find in the description below. This is known as NASA's EYES, or Eyes on the Solar System. But in this particular case, we can actually take a look at Saturn and its moons by, I guess, clicking right here, and then clicking on Enceladus. And the reason I wanted to take a look at this in this particular website is because it also simulates the geysers. You can see them being emitted from this area that looks like unusual tiger stripes, and you can actually learn more about this in one of the videos in the description, including how all of this works. But here, by accelerating time, you can even see the emissions almost as if you're right there around Enceladus. Although technically these are not geysers as much as they're cryovolcanoes. And the reason this is so exciting for scientists is because there is now a very strong belief that based on a lot of observations from the last few months, currently there's a really high chance that a lot of these cryovolcanoes are also emitting signs of potential life underneath Enceladus. In other words, Enceladus currently is the most likely candidate to find life outside of planet Earth. Not Mars, not Venus, not any other moon, it seems to be Enceladus. And though there is a mission planned to Enceladus that's going to be landing here in order to investigate potential signs of life, all of this is not happening until possibly 2050s. And so we're not going to know for sure for at least 20 more years. But all of these signs and all of these observations along with discoveries of similar moons around other planets, and more importantly, along with discoveries of quite a lot of exoplanets that seem to possess extremely similar density and potentially similar properties to these moons, led to a kind of a hypothetical proposition. What if this is actually where we find most life out there in the entire galaxy? And what if this is actually how life usually begins and how it normally stays for a long time? As a matter of fact, here on planet Earth, it is believed that life might have started around these hydrothermal vents deep in the oceans, which we also believe exist around these moons, and very likely exist quite a lot of other planets as well. These regions are usually filled with a lot of different life and represent very unique ecological niches that can survive in this state for a very long time. And so what if this is the face of most alien life out there? And so based on these assumptions, the recent study decided to discover the most likely planets to potentially be the same to Enceladus, thus representing planets with the highest chance for subterranean or technically subglacial life. And the main premise is simple. Life, as we know it, really needs water, liquid water. But except for planet Earth, we don't know of any other object out there that contains liquid water on its surface. Yet we know that some objects, and actually quite a lot of objects, seem to definitely contain liquid oceans underneath the ice. And so maybe that's where we should be looking, and that's the sort of planets we can kind of expect to host something out there. But why would they even have liquid oceans? Well, in order for these planets to maintain liquid oceans, they basically need heat coming from somewhere, and there are two main sources. The first one is the obvious one: internal heat from the radioactive decay of various elements that stayed inside the planet for billions of years. This can produce some of the internal heat and can also maintain some of the initial geological activity. But the other source is the same source as what we have right here around Enceladus, or actually most moons around large planets. Here we're talking about tidal effects or tidal heating. Tidal heating is the less known effect produced by various objects as they essentially pull and stretch each other because of gravitational effects. We mostly experience tides as the rising and falling of ocean levels. On a lot of other objects, including potentially the moon itself, all of this stretching and twisting also produces quite a lot of heat and quite a lot of energy on the inside. In some more extreme cases, it also basically breaks apart the moon with time forming the rings around certain objects, which is how we believe all gas giants acquire their rings. But in most cases, the moons don't fall apart and instead experience quite a lot of geological activity, such as for example the famous Io. All of the volcanism here is entirely caused by tidal heating from Jupiter and from its neighboring moons. And so something very similar very often happens around planets orbiting certain stars, especially when they're much closer to those stars, and especially in systems that do have several planets. And so for example, in the very famous TRAPPIST-1 system, where there are 7 terrestrial planets orbiting relatively close to their parent star, we actually expect relatively high tidal effects for pretty much all of these planets, especially the ones much closer to the star, with some of these effects very likely producing something very similar to Io. Huge amount of geological activity, potentially a lot of outgassing, and very likely lots and lots of heat for maybe life to survive. But for this particular study, the scientists decided to focus on planets that were maybe just a little bit colder than planet Earth, and also maybe a little bit less dense. The reason they wanted to find those planets are essentially twofold. First, low density implies that there might be quite a lot of water. Any kind of an ocean world, or any kind of a world with a lot of water on the surface, would most likely be slightly less dense than planet Earth, but potentially very similar in size and mass. And the reason they wanted those planets to be a little bit colder is obviously because they were looking for planets that would have ice surface. In other words, they wanted to find planets that would be kind of like Enceladus, just bigger and more massive, but also kind of like Io, in a sense that they would have a lot of volcanism or cryovolcanism, because that's physically something we can see with modern telescopes. And in this case, they've discovered 17 such planets that could be these unusual planets, maybe hosting life. So basically, all 17 currently have an extremely high chance to have a subsurface ocean and a lot of geological activity underneath, representing the best targets for potential biosignatures for modern telescopes. And you can see all 17 of them right here in this list. A lot of them we've discussed before, and some of them we've never really talked about, but for the most part, they're all relatively similar. They would all be somewhat similar to planet Earth, a little bit colder, experiencing high tidal effects. Intriguingly, at least 3 of these planets are in the TRAPPIST-1 system, and intriguingly, the closest exoplanet to us, Proxima Centauri b, is one of them as well. And so, for example, here's how they all kind of compare in terms of internal heating produced by a lot of tidal effects. Of all of them, Proxima Centauri b seems to have the highest tidal heating, whereas the TRAPPIST planets seem to have the lowest, but still kind of similar to planet Earth, which our planet experiences from the moon and from the sun. Io experiences just a little bit more, and as you can see, 9 of these planets seem to have more tidal heating than Io. And though obviously this means that maybe some of these planets look kinda like this, a much more likely scenario does involve these ice worlds with a huge amount of cryovolcanism that should be coming out from every direction, and then deposited somewhere around the planet or around the star system. And since modern telescopes can easily detect this around moons like Enceladus, and we know exactly what to look for, a very similar technique could now be used on those exoplanets by trying to find similar signals somewhere where those planets are. In other words, modern telescopes could physically detect some of this subsurface and geological activity by looking at very specific spectra coming from these cryovolcanoes. And this is something we can physically do now with planets like TRAPPIST-1F. Here's actually that other version of Eyes on Exoplanets that shows you what this planet might look like if it obviously has some kind of a subsurface ocean or maybe even surface ocean with a lot of ice. And because this planet passes in front of its star, it becomes possible to see its emissions, and if we happen to discover something that appears very similar to what we see around Enceladus or Europa, that's going to be a telltale sign that cryovolcanism seems to happen here, and these seem to be indeed larger versions of the moons in the solar system. Moreover, if we find life here, there's a really high chance it might exist here as well. And because unlike Enceladus, the mass of this planet is very similar to planet Earth, with just slightly lower density, this is definitely one of the most exciting objects. Here, a single orbit takes approximately 9.2 days, and so we can actually look at this planet many times to see if any cryovolcanism occurs during this time. But in the list of those 17 planets, 2 are really exciting, or I guess 2 are the best candidates so far, and they're not in the TRAPPIST-1 system. One of them is our neighbor Proxima Centauri b, the closest exoplanet around the closest star to us, roughly around 4 light-years away. Here, this planet is also just a little bit colder than Earth and is around the same mass with slightly less density. And according to previous research, it might look something like this. Although honestly, nobody really knows right now what sort of a composition it has, we just know that it has slightly less density. And because of this, one of the assumptions is that maybe it is covered with a lot of water and specifically has a very thick sheet of ice, with possibly 10 to even 20% of the entire planet basically being water. And because it seems to receive the most tidal heating of all the planets, this presents us with an extremely intriguing target. A planet that could be similar to Enceladus, but with more volcanism than Io. Something that would be super intriguing to investigate, except that there's maybe one problem. This is not a transit planet. It does not pass in front of its own star, and so unfortunately, we're not really going to be able to find any ices or any volatiles coming from this planet by looking at its shadow. Instead, something else has to be used in order to confirm what's going on here. Still, once again, this is one of the primary targets and a super intriguing object that, as you might remember, is also the object where scientists might have discovered the first ever extraterrestrial signal, BLC-1, although the conclusion today is that maybe that signal actually came from Earth. You can learn more about this in one of the videos in the description. Either way though, definitely target number 1. But what about target number 2? It's this other planet known as LHS 1140b, roughly around 40 light-years away from us, and, just like other planets, is also in the habitable zone, but slightly colder than Earth. Although unlike previous planets, this one is more massive than Earth at approximately 5.6 times the mass. And so technically this is maybe some kind of a super Earth, but also potentially a super Earth that's an ocean world with even more water and even more ice. But also, as you can see from this graph, hundreds of times more geological activity or tidal heating than the moon Io. And though we obviously have no idea what this planet really looks like, this is still an extremely exciting object and has a really high chance right now to also host a lot of life. And because the outgassing here would be extremely similar to what we see around Europa and Enceladus, confirming this is just a matter of time. Basically, by observing this with, for example, James Webb Space Telescope, it will definitely be possible to see these emissions, mostly because a lot of these molecules are extremely easy for infrared telescopes to detect. And so hopefully in the next few months, someone actually does analyze at least one of these 17 planets, just to provide us with some details and potentially some discoveries. Because at least for now, all of this is just purely theoretical. Nevertheless, at least for now, this is actually the closest we've come to physically finding objects out there with an extremely high chance for some kind of a life based on one assumption. Based on the assumption that objects like Enceladus and Europa also host life inside. And that's of course the first step. The missions that are planned to both Europa and then Enceladus later on are going to serve as a very important stepping stone in order to see if life can exist outside of planet Earth and if it's just as common as some scientists believe. And so if we do find life around one of these objects or even both of these objects, it's extremely likely that all of these 17 planets contain it as well. But the more important question is if we find nothing. If neither Enceladus nor Europa contain any signs of life, that's where we're going to find ourselves questioning everything we know about astrobiology. Maybe rare Earth hypothesis is correct, and maybe life is just as unique as some other scientists believe. Hello Info Person, this is Anton, and once again we have a discovery of a planet that shouldn't exist. A planet known as LHS 3154b, orbiting what's known as an M-type star or a red dwarf. And what makes this particular star system unusual is the fact that the planet, in terms of the size and the mass, is just a little bit too big for this particular star. Compared to a lot of other red dwarfs and compared to other similar star systems that technically represent the most common star systems out there, in terms of the size and mass ratio between the star and the planet, it just really makes no sense whatsoever. Here's for example how Earth compares to the Sun, and here's how this planet compares to its star. Way more massive, way larger than anything we expect in this type of a star system. And so let's talk a little bit more about what's happening here, how this planet most likely formed, and how this compares to other discoveries from previous studies, as well as the problems this sort of creates. First of all, where exactly is this, and what do we know about the star? Well, like so many other red dwarfs, this is just a low-mass star that in essence represents the most average star in the galaxy. It's about 9 times less massive than the Sun, and is therefore expected to only have terrestrial planets in its orbit, kind of similar to red dwarfs we already know. For example, the famous TRAPPIST-1 system that contains 7 Earth-like terrestrial planets in its orbit. And these systems are extremely common, they actually seem to be everywhere, but because they're usually the smallest stars in the galaxy, despite their numerous numbers, they're still kind of difficult to study, and there are still a lot of mysteries about them. And that actually includes the mysteries of how they form planets. It's assumed that it's very similar, kind of what we usually see around other stars, with some kind of a protoplanetary disk, where different overdensities eventually start forming larger and larger objects, turning into planets, but because they're so small, usually red dwarfs are just very difficult to study. But that's of course just an assumption based on observations from other stars. Nevertheless, relatively recently, scientists wanted to find out, how many of these stars could potentially have giant planets, basically planets that are not terrestrial. And so here they managed to collect data for every major red dwarf star in the 50 light-year radius from planet Earth, and specifically focusing on single stars, not binary stars, not active stars, in total discovering 200 various objects that could then be analyzed with a lot more detail. And so these 200 objects were then observed for 3 years. This was done to determine what sort of planets would be orbiting here and to try to find as many as possible. And in the end, they discovered that pretty much none of them seemed to contain giant planets. Yet they all contain terrestrial planets, similar in size and mass to planet Earth. There were maybe 2 potential candidates with something a little bit larger, possibly some kind of an ice giant and possibly something similar to Neptune. But because these planets were on the outskirts of the star system, essentially past the so-called snow line, it was a little bit difficult to confirm these planets, and it was also a little bit more difficult to study them or to try to understand how they formed. Either way, if we accept these 2 potential detections, it kind of presents us with approximately 1.5% chance for a red dwarf to have some kind of a Neptune-like world. But these ice giants can only exist on the outskirts, beyond the snow line, where there's enough icy material to start accumulating more gas and to form something a little bit larger. Much closer to the star, in the inner region, we don't expect anything like this at all. Everything here has to be terrestrial and possibly similar to Mars, Venus, and Earth. Not like in terms of conditions, just in terms of composition and overall density. Yet this discovery really makes no sense. This planet is way too close. And it seems to be approximately 13 masses of planet Earth, basically making it some kind of a Neptune-like or Uranus-like object. And so at this mass, it's most likely a gas planet. But it's unlikely to be an ice giant because it's very close to the star. A single orbit here is approximately 3.7 days, making this a relatively hot planet with very likely superheated atmosphere. Here this was discovered by using what's known as radial velocity, when essentially the scientists look at the star and they notice that it's sort of wobbling and produces redshift and blueshift effects with very specific periodicity. This can only be the result of a massive planet in its orbit. And here the mass was determined at 13 masses of planet Earth. This was also happening every 3.7 days, making this the orbital period. Interestingly, this technique doesn't actually work around Sun-type stars, because usually planets here are much farther away. So for example, planet Earth does not pull on the Sun enough for us to be able to see it in this way. I mean, once we have more powerful telescopes, it's going to be possible, but just not yet. But for M-type stars, this is definitely a possibility, and a lot of planets have been discovered the same way. The problem is that the planet here was pulling on the star way too much, making the redshifts and the blueshifts much higher than anything we've seen before. Here you can actually see that the star in this case changes its velocity by approximately 23 meters per second every 3.7 days. That is a pretty substantial change that can only be caused by something very massive. And so this planet is definitely there. But why is it there? Or how is it there? These types of stars should not be able to form anything similar so close to the star. Previous detections were preliminary and always on the outskirts. This is practically hugging the star. And in modern astronomy, red dwarfs are not expected to have large enough planetary disk or even have enough solid materials to form a planetary core that can then become a gas giant. So either this particular star had a much larger planetary disk, possibly 10 times as massive and 10 times as large, which would then need to be explained in some other way because we should be seeing more planets in this case and possibly a lot more stuff, or the more likely explanation is that maybe despite all of the protoplanetary disks we've seen so far, and despite confirmations for planetary formation from various studies, there's at least one other way planets can form that we didn't know about before. In other words, maybe giant planets can form in some other way we never knew about. Possibly from some kind of a gravitational instability and some kind of a collapse of material into a large planet, or possibly through some kind of a, I guess, binary-like system where instead of two stars you have a star and a large planet. Or possibly we don't really know. Actually, nobody knows right now. This is a new mystery. Right now, all of the planetary simulations and different assumptions about how this formed do not explain everything and don't really make a lot of sense. This star should definitely not have this planet, and this planet does not belong in the location where it currently is. And though it's possible that maybe this type of planet could be captured by the star, in this case because it orbits so close to the star and seems to have a relatively perfect circular orbit, once again it just doesn't make sense. A captured gas giant would be somewhere on the outskirts or would have an extremely eccentric orbit that would look very different from what we see. And so definitely quite a lot of questions to tackle and quite a lot of mysteries to try to answer. How, why, and what is it doing here? But that's of course one of many mysteries scientists are trying to answer about M-type stars. These stars are so common, yet we know so little about them because they're so difficult to see. And we obviously know even less about their planetary formation or what sort of planets they even form. But because of systems like TRAPPIST-1 where 7 terrestrial planets seem to be in orbit, understanding these planets and how they form would actually help us understand if life can exist somewhere else, and if one day we could discover some kind of a habitable planet around these very common yet very unusual stars. Okay, that's unfair. These are not unusual stars, they're actually super common stars. It's the Sun that's unusual. And you can learn more about that particular topic in one of the videos in the description. And you can also find a few more videos about strange exoplanets or planets that shouldn't exist that we've discussed previously. So today I wanted to discuss a really exciting planetary system that was recently confirmed by scientists using some of the older data from the Kepler telescope. The iconic NASA telescope that's now officially retired, that essentially helped us enter a kind of a golden age for exoplanetary discoveries, helping scientists discover and confirm over 5,000 actual physical planets in other star systems out there. And though by itself today this is not something that's super exciting, here I think it's important to remember that just a decade ago we barely knew about any of these planets and none of this was possible. But when it comes to studying various exoplanetary systems and trying to figure out how planets form, it's really the multiplanetary systems that are the most exciting, especially the ones with more than 6 confirmed planets. And naturally, the most famous and the most exciting system so far is the famous TRAPPIST-1. But this was not discovered by Kepler. It was actually discovered using a TRAPPIST system on the La Silla telescope, located right here on planet Earth in Chile. A telescope that's of course known for a lot of other discoveries. And so after the confirmation of the TRAPPIST-1 system, one of the main goals for many astronomers has actually become trying to find more of these similar systems, basically multiplanetary systems, in order to figure out how planets form, what sort of a distribution of planets there is in these systems, and how it compares to, of course, the solar system. And up until recently, the TRAPPIST-1 system was the only system known to us containing 7 planets. But now the scientists discovered another one, and as you might have guessed, it's from the data out of the Kepler telescope. Although here I have to mention something else that we're going to discuss at the end. There is actually another system that contains 8 planets. And no, it's not the solar system. There is another Kepler star system that's a little bit less well known. But anyway, what exactly was discovered extremely recently? Well, because of the extensive observations of the Kepler telescope of several specific regions in the galaxy, over the years it collected a huge amount of data. Data that's still being actively processed using modern methods in order to find out if something was missed previously, or in order to confirm previous observations by potentially using additional methods. And during some of the initial stages of Kepler's observations back in 2014, it was able to analyze and discover 2 separate planets in a star system of Kepler 385. These planets were confirmed pretty quickly, but it wasn't until 2020 that the 3rd planet was confirmed as well. All 3 were relatively massive and relatively large, and potentially represented some sort of a Neptune-like gas giant with somewhat hot atmosphere on the surface. And that's because all 3 were relatively close to the parent star. The star itself was also relatively hot, about 10% larger and about 5% hotter than the Sun. This is what's known as the F-type star. And so for a very long time this was not actually a very exciting star system. A lot of very similar star systems have been discovered over the years. Obviously very different from the solar system, but similar to other star systems out there. And yeah, that obviously makes the solar system the odd one out. But extremely recently, the scientists behind this recent paper reanalyzed a lot of data from Kepler, combining it with observations from the ESA's Gaia telescope. In essence, improving the observations from various transit durations, as many of these planets pass in front of their stars, which then allow them to create a new, extremely accurate catalog with 700 multiplanetary systems and over 4,000 planets reanalyzed with a lot of detail, which in the process also allowed them to recalculate orbits of various planets, even determining their eccentricity. And in this catalog, they were able to confirm that the star system Kepler 385 seems to be the 2nd ever system discovered to contain 7 planets, making this the only other system except for TRAPPIST-1 with 7 confirmed planets. But unlike TRAPPIST-1 system, this star is very different. This is not a red dwarf. As I mentioned, this is an F-type star. And all 7 planets are much closer to the star than many of the planets in the solar system. And all 7 planets are larger than planet Earth, but just a little bit smaller than Neptune. Most probably classify under what we refer to as the hot Neptunes, which just happen to be some of the most common planets discovered out there, with the overall radius of all of these planets being at least twice as large as planet Earth, but also containing thick atmospheres and obviously extremely hot atmospheres, much hotter than Venus. But the nearest 2 planets are potentially rocky. They're just a little bit larger than Earth, but may contain no atmosphere whatsoever and possibly resemble some kind of a really large Mercury. In essence, making this a somewhat unique star system. Once again, 7 planets, 7 very different planets, and obviously much different from anything we've seen in TRAPPIST-1 or right here in the solar system. And obviously right now there are no additional discoveries coming from the star system yet, there is a chance we might hear more about it just because now the system is definitely in the spotlight. But there is maybe one slight problem here. Unlike TRAPPIST-1, which is only 40 light years away from us, this here is about 100 times as far away, over 4,700 light years away from planet Earth. So yeah, studying this with a lot of telescopes is still going to be somewhat challenging. Even the James Webb Space Telescope might struggle to identify certain features around atmospheres of these planets. But in terms of importance of this study, it's actually the analysis technology itself that's really intriguing here. Because normally there was never enough information to try to calculate the shapes of orbits of various planets. So normally it was difficult to tell if the orbits were circular or more eccentric. But this time researchers developed a new method, allowing them to calculate eccentricities for a lot of different exoplanets in the catalog, helping them identify additional features. And so by focusing on accuracy and orbital periods, the researchers here identified that it looks like star systems with more planets generally have more circular orbits. In other words, the more planets you have, the more circularization seems to happen for most planets. And so discovering planets in these multiplanetary systems with unusual orbits is definitely worth investigating, because it just means something extreme must have happened here for those planets to acquire these unusual orbits. So definitely some really exciting discoveries. But as I mentioned before, this is still not the record holder when it comes to the number of planets. It just so happens that the Kepler telescope was able to discover something else back in the days. And though there are actually quite a lot of different systems with at least 6 planets, and now we have 2 star systems with 7 planets, there's only one exoplanetary system discovered so far that has a similar number of planets to the solar system. And that's the system of Kepler-90, whose orbital parameters you see right here. And here once again, all 8 planets are larger than planet Earth, but are also within approximately 1 astronomical unit away from the star. And by being a star extremely similar to planet Earth, it means that only the planets on the outskirts have a potential to be maybe habitable. And in this case, it's this planet right here, planet H. But planet H is most likely a gas giant. Very similar to Saturn, very different from planet Earth. And so obviously if this one has moons around it, they do have a chance to be maybe habitable. But the moons here would be very difficult to discover because this is also pretty far away. Almost 3,000 light years away from planet Earth. Nevertheless, this is actually a really exciting star system just because of another really important fact. The configuration of planets here seems to be kind of similar to the solar system. Gas giants on the outside, much smaller planets and especially rocky planets on the inside. Surprisingly, we don't actually see this very often. But all 6 inner planets seem to be either super-Earths or mini-Neptunes. So none of them are actually terrestrial or similar to planet Earth, with one of them, planet Kepler-90g, being particularly strange. It seems to be extremely inflated with an extremely low density of 0.15 grams per centimeter cube, representing what's known as the poofy planet. And this by itself is already mysterious because nobody knows how these planets form or why this planet exists in this star system. And so Kepler-90 and Kepler-385 right now are essentially going to be really exciting to study because of the number of planets confirmed here. But the data from Kepler telescope is still being analyzed even today, and so there's actually a really high chance that some other star systems, like for example this one right here that has 3 unconfirmed planets and 6 confirmed planets, might actually become even more exciting because they'll now contain 9 confirmed exoplanets, even more than the solar system. I guess technically, if you don't consider Pluto to be a planet. And so with better analytical methods and new techniques, and also more observations from the Gaia telescope, all of this will probably become possible in the next few years. So pretty much every month now, someone out there discovers an unusual exoplanet. A planet that's too big, too small, too hot, or maybe too cold. And in the last year or so, there's already been over a dozen different videos on the topic of unusual exoplanets. But with even better telescopes and more accurate observations, scientists keep discovering planets that are even stranger. And today we're going to discuss one of these planets that we've actually briefly discussed a couple of years ago. Hello wonderful person, this is Anton, and this is a planet known as Gliese 367b. The planet that also received a proper name, and so it's sometimes referred to as Tehei, orbiting a star named Ananusa. And these names were taken from various flowers in Chile, mostly because one of the Chilean telescopes played a role in confirming these exoplanets. But originally, this particular star system and this planet was investigated by the NASA's TESS telescope, basically the sequel to the planetary search that started with Kepler. And TESS so far has been very productive in discovering various exoplanets. And back in 2021, it detected an unusual dip around a star system approximately 30 light years from planet Earth. But interestingly, this dip was happening very frequently, every 7.7 hours, which by itself meant something really unusual. It meant that this planet was orbiting super close, one of the closest orbits to the parent star. So close, as a matter of fact, that if you were to simulate this, it would maybe look something like this. And as you can see here, there's a long tail behind the planet. That's probably because it's also evaporating a lot of things from its surface. This planet is pretty hot. The current calculations for temperature suggest that it's close to about 1500 Celsius, 1700 Kelvin, or 2700 Fahrenheit. And that's despite the fact that the star is just a red dwarf. So because of the proximity to the star, at least on the day side of this planet, it's most likely extreme. And this is very likely also tidally locked, always facing with the same side toward the star. We obviously have no idea what's happening on the other side. And so because it seems to receive approximately 500 times as much radiation as planet Earth, and because it was so easily visible with the TESS telescope, it became one of the most intriguing discoveries. And because of the proximity to the star, it was also possible to measure the mass of this planet as well. It's actually done using what's known as radial velocity. Here, by looking at the star and how it basically wobbles around the planet, it becomes possible to work out the exact mass of this particular object. And so by knowing how much the star wobbles, which is usually done using redshift and blueshift differences, and by using ESO's HARPS instrument, High Accuracy Radial Velocity Planet Searcher, it became possible to make first announcements about this very strange planet. It seemed to be very dense, way too dense to be made out of just rock or gas. But these were announcements from 2021. Since then, this planet was now observed for over 2 years with over 360 different observations and calculations, allowing the scientific team behind the recent paper, this paper right here, to essentially work out several more things about this planet, but in the process also find 2 of its partners. And so here's what we basically know so far. First of all, when it comes to the properties of this unusual planet, it is as extreme as it comes. At the moment, it's believed that this is maybe an iron planet, or some kind of a metallic world we've never seen before and never thought possible. Now, more officially, these are known as super Mercury planets, usually planets with extreme density and potentially relatively close to the star. But in terms of this world, it's really extreme, it's just hard to explain. So for example, it seems to be about 63% the mass of planet Earth, but it's also about 70% as large as Earth, which means that its density is close to about 10.2 gram per centimeter cube. That's practically double of planet Earth, and Earth is already the densest planet in the solar system. Which does imply that whatever this planet is made out of, it's something really dense. It has to be metal. Here the implication is that maybe at least 91% of this whole planet is made out of iron-nickel core, with maybe just a little bit of extra stuff on the surface. To some extent, this might resemble the Psyche asteroid that NASA is going to be exploring very soon in the next few years, because this is also believed to be an ancient planetary core, but just maybe a leftover, something that never became a planet. In this case though, much larger, much more massive, definitely a planet. Intriguingly, this is also the smallest and the second least massive planet within about 40 light years from planet Earth, so quite a few records. But because of those additional observations from the TESS telescope, 2 more super-Earth planets were discovered in the same system. One seems to orbit every 11 days, and the other every 34 days. Although not a lot is known about these 2 other worlds. They're not visible with TESS. But the biggest question that nobody can answer right now is, what exactly happened here to create this planet? How exactly can this planet exist in this somewhat normal star system? And well, at the moment there are 3 potential explanations. Although to try to first explain this, scientists wanted to find out exactly how old the system is. And strangely enough, initial observations suggest that this is actually a relatively young system, maybe 60 million years old. That's basically like 100 times younger than the solar system. And what's even stranger about it is that it seems to be orbiting in a somewhat eccentric orbit around the galaxy, which potentially implies that there was some kind of a gravitational interaction with something else early on to put this star on this unusual orbit. So maybe it experienced some kind of a very close passage with another star earlier in its lifetime. That could maybe explain one of the potential reasons this planet exists. Because maybe this planet started as something else, something similar to Neptune or Uranus. Essentially, if it was a gas giant, it could have contained a relatively large iron core. But due to some kind of a gravitational interaction, or maybe even due to planetary interaction of some sort, it lost its far orbit, moving much closer to the star, eventually finding itself very close in the orbit it has today. And at these distances, the gas giant would be stripped completely of everything on its surface. This concept is actually known as Chtonian planets, and we've discussed several such discoveries in the past, where quite a few have already been discovered around the galaxy. Here's one called Coret 7b. But because this is such a young star system, all of this would have to have happened really fast, within just a few million years right after the star was formed. By itself, it's kind of difficult to explain. It's also quite possible that maybe this planet was similar to a typical terrestrial planet or even a super-Earth, but because of the interaction with the other two planets that have recently been confirmed, moved much closer to the parent star, thus explaining what happened to it afterwards. So that's the first possible explanation, migration of the planet toward the star for some unusual reasons. But that's also not a very likely explanation, because as I mentioned, this seems to be a very young star system, and so for that planet to lose everything in such a short time, that will require some really extreme effects. At the moment, kind of difficult to explain. The second explanation is maybe a little bit less extreme. This planet could have formed normally inside a protoplanetary disk, but in this case maybe the disk itself was somewhat unusual. It might have had some kind of an iron-rich region where this somewhat strange planet formed just like your typical terrestrial planet. But to date, no such disk has ever been seen anywhere, making this explanation not very popular either. With the third explanation, being some kind of a planetary collision. If this planet collided with something else, it might have stripped the surface of the planet, leaving behind a very dense core, with this collision also influencing the orbit of the planet, moving it to the closer location around the star system. But previous studies, including actually this study, do suggest that collisional stripping as it's known, or basically removing the upper layers because of various collisions, is just not very efficient at producing dense iron planets. It's possible, it's just very unlikely. And so at the moment, none of these three explanations, collisions, iron-rich protoplanetary disks, or planetary migration, seems to actually explain what's going on here. But because of previous discoveries of similar planets, these super-Mercuries, it essentially suggests that this is a relatively common phenomenon. And it also seems to be related to multiplanetary systems, where the star often contains much larger, more massive objects, slightly farther away from these unusual dense planets. So kind of similar to what we have here in the system of Gliese 367. So at least as of today, it's basically a new mystery. Nobody knows how these planets form, we don't even know what they're actually like on the surface, or what sort of metals they're made from. They're just extremely dense, and very likely completely different from anything we've ever imagined. So years ago, when I was just starting this channel, it was actually pretty uncommon to hear about very strange, very unusual planets. Strange exoplanets that would defy our understanding of what a planet actually is. But with more and more discoveries in the last 5 to 10 years, it sort of became a common occurrence. Discovering a strange, unusual, and completely unexpected planet is now not surprising at all. But I guess still worth talking about. Hello wonderful person, this is Anton, and in this video we're going to be discussing a recent discovery of what seems to be an unusual planet, an unusual exoplanet, that essentially has a density very similar to typical cotton candy, over 100 times less dense than planet Earth, and very similar to what you find inside cotton candy. And although officially these types of planets are known as superpuffs, unofficially they're known as cotton candy planets. Probably some of the most difficult to explain exoplanets out there, but the planets that definitely seem to exist because this is not the first such discovery. And so let's discuss what was discovered here, what this means for astronomy, but I guess let's start with other similar planets discovered in the last few years. Now here it's a little bit difficult to simulate exactly what these planets look like because obviously we have no idea, but this was one of the first such planets discovered, Kepler 87c. Originally discovered back in 2013, or about 10 years ago, by the now retired Kepler telescope. And what really stood out about these types of planets was the fact that they were actually really large in size. Much larger than Jupiter, but unlike gas giants similar to Jupiter, they were not very massive. They would usually have a mass of just under the mass of Neptune. And here in the solar system, it's the Saturn that's the least dense planet of them all. Here the density is just a little bit less than the density of water. Which of course means that, yeah, if you have a large enough ocean, Saturn would not sink and instead would float on the surface. And our home planet, Earth, has the highest density of all of the planets. It's approximately 8 times as dense as Saturn. And this is mostly the result of an extremely large iron-nickel core on the inside, which is probably also the reason why our planet has so many other unusual properties, including a powerful magnetosphere. But a density of a typical superpoof would be 1/100th of planet Earth or over 1/10th of Saturn. Here we're talking about values of about 0.05 gram per centimeter cube, whereas the density of planet Earth is about 5.5 grams per centimeter cube. And although at first it was not actually certain if these planets are real and if it's maybe some kind of a fluke in measurements, more and more such planets started to be discovered in the last 10 years. With the biggest mystery being the star system of Kepler-51. Here it was discovered to contain 3 separate exoplanets, and all 3 seem to be superpoofs, super poofy planets. Planets whose densities were close to about 0.05 gram per centimeter cube, but that were basically Jupiter-like in size, even though they contained very low mass. And surprisingly, unlike other similar planets known as the hot Jupiters, some of these planets were not very hot. They were inflated, they had low density, but the temperature here was not super hot. For example, the temperature for Kepler-51d, the farthest of these superpuffs, is suggested to be actually kind of close to planet Earth. But even though its mass is also a little bit higher than planet Earth, its radius is at least 10 times as high. And it's kind of unclear why these planets are like that. Or I guess to be more exact, why this particular star system contains 3 such planets. Now there are some potential explanations that we're going to discuss in a couple of minutes, but the exact reasons are still unknown. And in case of this star system, it's believed to be approximately 500 million years old, which means that these planets should have already evolved and should have already reached their final size and final mass. Yet all 3 are bigger than Jupiter in size, even though their mass is very low. Which of course implies that maybe there is some sort of a mechanism responsible for forming such planets that seems to be very prevalent in this particular star system. But that's not something we're going to know for a while. But this time, the scientists discovered yet another one of these planets, even to some extent stranger than before. This is about 1200 light years away from planet Earth, and it's a planet known as WASP 193b. Once again, its mass is only a few times more than planet Earth, implying the density of about 1% of Earth density. But in this case, presenting us with a slightly different star system and a slightly different planetary arrangement. In this case, the star seems to be very similar to our Sun. It's a little bit more massive and also a little bit larger, but overall this is a G-type star. A relatively rare type of a star in the galaxy, but the type of a star that's extremely interesting because we kind of expect it to be perfect for Earth-like planets. Unlike other similar planets though, this one seems to be very close to the star. Here, a single orbit seems to be about 6.2 days, which of course means that the temperatures here are also very hot, roughly around 1200 Kelvin, or about 1000 Celsius, approximately 1800 Fahrenheit. But because of the density of about 0.059 grams per centimeter cube, it officially makes this yet another superpoof or cotton candy planet. But very unusual one and different from the ones before. Extremely hot, implying that maybe something else is going on here compared to planets in Kepler-51 system. And here's how those planets compare to the ones in the solar system. So all 3 planets here are not that hot, but are definitely much more inflated and contain extremely low density. Here though, it's not just puffed up, it's also very hot. And currently this doesn't really make a lot of sense. Especially because this is not a young star system. The star here is about 6 billion years old, so if this was actually a result of evaporation, for example, this planet should have lost all of its extra atmosphere a long time ago, assuming a permanent lower density. And based on previous simulations and previous modeling, it's believed that such a planet could maybe exist for a few million years, assuming that hydrogen and helium are actually responsible for the inflated size. But because we're talking about a star system that's 6 billion years old, it's extremely unlikely that we actually find ourselves looking at a planet that's going through this extremely volatile stage. Because here it would then be impossible to answer the question of what is this planet even doing in this location? Shouldn't it be much farther away where we usually find planets like Jupiter? And so at the moment there's really no good explanation for what the scientists just discovered. Now it's obviously there and it's obviously real, and all of the observations so far seem to confirm its density and its really large size, but because of other parameters such as the age or the proximity to the star, at the moment it makes no sense. Naturally, once there is a solution, it can definitely help us figure out the evolution of other planets as well. For now though, there are maybe a few potential explanations. Okay, so one of them is that maybe it involves some kind of a continuous loss of atmosphere for one reason or another. And what we're actually looking at here is not really the atmosphere as much as the top of the atmosphere represented by some kind of dust. So one potential explanation is that this is some kind of a weird, dusty planet with the dust coming from within and sort of floating above the atmosphere. So kind of like what we have on Mars when there's a dust storm, but dramatically more powerful and essentially going way beyond planetary boundaries. But the other explanation is that maybe what we're actually seeing are the rings of the planet. Maybe because of the positioning toward the star, it's just very difficult to tell apart the rings from the overall atmosphere of the planet. And we actually talked about the largest ring planet ever discovered a few years ago, the planet sometimes referred to as V1400 Centauri or J1407b, but even here, one of the recent discoveries that you can find in the description below suggests that maybe this planet is actually not ring planet after all. You can learn more about these updates in the description. And so having these extremely large rings is still kind of unlikely, especially in a multiplanetary system where all three planets for some reason would have these large rings. Now it's not impossible, it's just kind of unlikely. So I was actually trying to find a really cool example of the concept of counter-Earth. The idea that's very common in science fiction for the existence of another planet on the opposite side of the Sun. But turns out that this is a big cliché. It's been used in a lot of different science fiction movies, science fiction stories, science fiction TV shows, and is basically one of those ideas that seems to come up very often because it does make for a pretty cool concept. But the reason I wanted to bring this up is basically because I wanted to start with this as the explanation for what's known as the Lagrange points. The 5 gravitational points created by the interaction between Earth and the Sun that essentially form locations where you can technically place an object and it's going to orbit just fine. With the counter-Earth point being L3, L2 being the point where we have James Webb Space Telescope basically orbiting this invisible point created by Earth and the Sun, L1 being the opposite point located between Earth and the Sun, and L4, L5 representing two other really unusual points where we do actually often find objects in relatively permanent orbits, and we often refer to these objects as Trojans. Although technically it's Trojans and Greeks, and this is mostly based on the observations from Jupiter, which seems to contain millions, if not possibly even billions, of these objects. Thousands of big ones have already been discovered, and we do have a mission, and NASA's Lucy mission that was launched approximately a year ago, this is 2023, so back in 2022, is on the way there to try to essentially explore them and to try to figure out what's really happening here. Okay, so Trojan points exist. We're all clear, right? Alright, hello wonderful person, this is Anton. Today we're going to be talking about a really exciting discovery from a pretty well-known exoplanetary system. What seems to be a Trojan planet. Basically a planet, or some kind of a planetary object, occupying the location that's already taken by another planet. In other words, imagine if this is Earth, it's like finding another planet either in L4 or L5 points. Which is actually super exciting for another reason we're going to discuss near the end of the video. And so let's discuss what was discovered in this case and what all of this means, and of course, where all of this is located. And I guess let's start with the location. So this is not too far, not too close. And it's a system that we've discussed many times before, because it became the first where scientists officially observed an exoplanet using a technique known as direct imaging. In other words, by looking here directly with a relatively large telescope, they were able to physically see a planet in orbit around the star. This is a system known as PDS-70. It sort of looks like this. It's around 370 light years away from planet Earth, and it's a relatively young star system, with the star slightly smaller than our Sun, but also very young, about 5.4 million years old. Our Sun is about 4.5 billion years old. And previous observations definitively discovered at least two major exoplanets, PDS-70b and C. Both of them were directly imaged by the Very Large Telescope from the European Southern Observatory. By the way, PDS here stands for Pico dos Dias. It's a name of a Brazilian observatory whose main goal back in the days was to discover pre-main sequence stars, or basically baby stars, in order to create a kind of a catalog and to then learn more about star formation, star evolution, and of course baby stars. But in this case, this baby star is also forming baby gas giants, objects that will probably at some point become similar to Jupiter or Saturn. But the last time we've discussed this particular star system is actually because one of these planetary objects was discovered to potentially contain a moon-forming disk. Basically, it was also forming exomoons. Technically, this would make it the first exomoon visually confirmed to exist somewhere out there, even though this is a baby exomoon and a baby exoplanet. Still pretty exciting. But this time, by conducting additional observations, the researchers behind the study you can find in the description found evidence for something we've never seen before. A very tiny blob in the same orbit as one of the planets, the closer planet PDS-70b. But more excitingly, it seems to be in the location where we expect one of the Lagrange points. Or basically this is some kind of a Trojan object in the orbit of this gas giant. But it's not really a very large object. Current estimates put its mass at maybe twice the mass of the moon, Earth's moon. So something like 4 to 5% the mass of planet Earth, which is still definitely much more massive than anything in the orbit of Jupiter, and way bigger as well, but obviously not as big and not as massive as something we would expect from a planet in this star system. Here it's actually more comparable to some of the moons around Jupiter, both in terms of size and mass. Although to be more exact, here we don't really see the physical object as much as an accumulation of gas. It's actually visible right here, with the planet to the left side. And so there's definitely something in the orbit, and it's definitely something a lot less massive. But as you can see, none of this is developed, none of this is solid yet. And so in essence, this shows us how various star systems evolve, what happens in the beginning in the first few millions of years, and how certain objects can form in similar orbits. But this has a very important implication, or I guess ramification, for the theories behind the formation of Earth's moon. Because that's exactly how scientists today believe Earth's moon was created as well. Not by being created as a Trojan and being captured, but instead another smaller planet that we refer to as Theia was created in one of the Trojan points around planet Earth, which then collided with early Earth, eventually producing the moon that you see on the right and modern Earth that you see on the left. And that's of course the best explanation we have right now for the existence of Earth and the moon and for why they're so similar and a lot of other properties as well. And so this discovery right here is almost exact evidence we needed to kind of explain that this does seem to be pretty common, and some planets that contain Trojans that are maybe a little bit less stable can actually eventually collide, thus forming new objects, including new moons. And here it's important to add that L4 and L5 Lagrange points are not permanent positions. Depending on interactions with other bodies and depending on slight variations in orbital parameters, such as due to eccentricity, any Trojan here eventually can lose its orbit and find itself somewhere else or even collide with the planet. And so this blob of gas that's going to become a planet sometime in the future might actually suffer a similar fate, either colliding with something or escaping this orbit and assuming an orbit somewhere else. That mission I mentioned previously, Lucy mission, is most likely going to provide more answers about Trojans once it arrives to its destination in the next few years. It's actually going to be visiting its first Trojans, Jupiter's L4 Trojans, sometimes in 2027, and then visiting L5 Trojans approximately 4 years later. Either way, at least for now, this is definitely the first ever Trojan planet ever discovered, or the first ever co-orbital planet seen anywhere in the entire universe. And that means that it definitely has to have a really cool name. As a matter of fact, modern astronomy doesn't even have a way to name these planets just yet. Like, would this be PDS-70b2, BB, B Junior? Yeah, no. Let's just give it a really cool name instead. Feel free to make suggestions in the comments below. But it's actually quite likely that many of these stars have these Trojan objects. It's just this is the first we've discovered so far. Even in the solar system, Trojans are pretty common around other objects as well. Now Jupiter has the most, Neptune has a few, but even our own planet has a couple of large rocks inside its L5 Lagrange points. We've discussed them previously, but this is definitely something that's pretty common everywhere. And so chances are a lot of other similar baby planets have these objects somewhere out there, it's just we haven't really seen them yet, mostly because the telescopes were just not powerful enough yet. So let's start the video right here around Venus. You're probably aware that Venus is already really hot, but it's actually supposed to be even hotter. Even though the average atmospheric temperature here is about 460 Celsius or about 870 Fahrenheit, because of the proximity to the Sun, very thick atmosphere and all of the CO2, the temperature here is supposed to be much higher. I remember doing some calculations and it's actually something like 800 Celsius on average. And the reason Venus is much cooler than it should be is because of what's known as albedo, the property of reflectivity of a certain object. Although albedo by itself comes from the root alba, which means white. So it can also be described as the whiteness of the object. And because of various aerosols in the upper atmosphere of Venus, it's very reflective. Its albedo is approximately 0.76, which is one of the main reasons why we don't even see the surface. But obviously it's not really a mirror, because the light that's reflected here is more or less diffuse. I mean, technically you could use computer simulations to try to work out the original image that's reflected here, but because all of this involves very unpredictable atmospheric conditions, this would not be very easy. The point here is that 76% of all light striking the upper atmosphere is reflected back into space, making this the most reflective planet in the solar system. In contrast, Mercury is extremely low in albedo and does not reflect much, and our home planet is somewhere in between. The average albedo for Earth is about 0.3. Although here things do actually differ quite a lot depending on what you're actually looking at. So for example, things like snow and ice are approximately 80% reflective, which is why the more ice there is, the more the planet reflects the heat, and the more likely it's going to maintain cool conditions. Intriguingly, this is also one of the reasons why during the glaciation period, it was very difficult for Earth to warm up to melt all the ice. It was just reflecting all of the light. In contrast, water does not reflect as much and is thus able to absorb more heat. Then we also have clouds that do reflect things as well, and so for places like Earth, the albedo effects are actually extremely dynamic and play a very big role in maintaining atmospheric temperatures or in dramatically changing conditions on the planet. Okay, well that's the solar system. Hello wonderful person, this is Anton. Today we're going to be discussing something else discovered really far away, that the scientists are now describing as the most reflective exoplanet discovered so far, although the press release from the European Space Agency unfortunately used the word mirror. Yeah, no, that planet does not act like a mirror at all. It has a very high albedo, but it's not going to be producing a picture of your face if you look into its atmosphere. Anyway, so what exactly was found, and why is this planet kind of exciting? So once again, this is one of those planets that technically shouldn't exist, or at least it's a planet that we didn't think would exist. It's approximately 4.7 times the radius of planet Earth, it's also about 29 times as massive as Earth, so in some sense, it's what's known as hot Neptune. It's actually orbiting around its parent star at a relatively close distance, with a single orbit of just 19 hours. But its size to mass parameters are not really very common. This is actually one of the rarest planets discovered so far, but most of its features are probably due to its extreme heat. Temperatures of 2100 Kelvin, or about 1800 Celsius, 3300 Fahrenheit. Right now this is believed to be the hottest such planet ever discovered. Not the hottest planet, just the hottest hot Neptune. But the reason the scientists think this planet should not exist or was never found before, or why this planet is in so-called Neptunian desert, is because if you look at the mass to orbital period distribution, you're actually not going to find any Neptunian planets in orbits very close to the star. And here it's defined as an orbital period around the star of less than 4 days, where these ice giants or Neptunian planets receive huge amounts of radiation and thus most likely cannot retain their relatively light gas atmospheres, eventually evaporating, leaving behind some kind of a core. These cores generally have a name, they're known as Chtonian planets. You can learn about previous discoveries of these unusual planets in one of the videos in the description. And so having these gas giants, similar in mass to Neptune, orbiting so close to the star is technically completely unexpected. Yet this object known as LTT 9779b seems to be there, at a distance of 260 light-years away from planet Earth, and more importantly, producing relatively strong albedo. In case you're wondering how this was discovered, here what the scientists usually do is observe the planet as it orbits around the star, noticing these slight changes in brightness. But in this case, they realized that this planet was actually reflecting a lot of light, almost definitively suggesting that this was a planet with a albedo of approximately 0.8 or even higher. So about 5% higher than Venus. But it is, generally, very similar to Venus in its overall albedo and possibly even in its appearance. Both planets are expected to have very similar whitish atmosphere if seen from the outside, although in case of this exoplanet, because its temperatures are much higher, it's also most likely glowing in a relatively dim red light, especially on the far side of the planet. But overall, it might look something like this, possibly a more reflective, shinier version of Venus, but also dramatically larger in size. It's even larger than Neptune actually. But the question here is, of course, what's happening with this planet, why is it so reflective, and how is this planet even possible? Well, the only explanation right now that makes sense is in regards to the clouds that seem to circulate around the planet and the atmospheric content. It's unlikely to be similar to Neptune or Uranus or any other common gas giants. It's actually extremely likely to have clouds made out of heavy metals, things like, for example, titanium, and even things like silicates or basically rock, with the current model suggesting that there are several layers, one being titanates or gas of titanium, another one being silicates or particles of glass circulating above, which has two potential effects. One is the increased albedo or reflectivity of the planet, and two, because this gas is much heavier since it's made out of bigger atoms, despite the proximity to the star and despite this being a gas giant, it's able to create a permanent atmosphere that does not escape and actually stays around the planet, forming a very unusual cloud deck. And here honestly, it's even difficult to imagine what any of this would look like. We essentially have a gas giant that contains silicate and metallic atmospheric conditions, with these metallic clouds allowing this planet to become so large and to then also become so reflective. But since this planet is also slightly more massive than Neptune, it also has more gravity to hold on to a little bit more atmosphere. And so it's most likely a combination of different factors that allows this planet to physically exist and to possibly even maintain permanent atmosphere without losing too much. It's also quite possible that this planet was a lot larger before and potentially contained a lot of other gases, but they probably escaped over time, especially as this planet migrated across the star system and moved closer to the star. Because that's probably what happened here. It's quite unlikely that this formed so close to the star, because if it did, there's really no explanation for how this could have happened. And so even though at these temperatures we do expect the atmosphere to completely disappear through evaporation, it's clearly not happening, and the planet is real and definitely seems to have a very thick atmosphere, inflated to almost 5 times the size of planet Earth. But if it's the amount of these metallic elements that allows this planet to exist, where exactly did all of these metals come from? Generally, we don't expect gas giants to contain that many, so there's maybe a chance that it did involve some kind of a planetary collision. Or maybe it basically ate one of its smaller neighbors, which could have also resulted in the change of orbit, making the planet approach much closer to the star. Although naturally, similar metallic conditions and metallic atmospheres have been seen around much more massive planets similar to Jupiter. It's just a little bit more difficult to explain when a planet is less massive, and especially when a planet is very similar to Neptune or Uranus. So definitely a pretty unusual and a pretty cool discovery. But when it comes to albedo, or I guess being a mirror, yeah, no, it's definitely not a mirror. And its albedo is not even that surprising either. As a matter of fact, there's an object in the solar system whose albedo is much higher. More than one object actually. For icy objects like Enceladus, the moon of Saturn, the albedo is about 1% higher than this planet. But the mysterious dwarf planet known as Eris, discovered on the outskirts of the solar system, has an albedo of 0.99%. This object right here reflects 99% of all of the light striking its surface. And most likely because of a relatively smooth surface, but also because of a certain type of ice that seems to cover the entire surface as well. It's actually not entirely clear why it's so reflective, but it definitely is. And so chances are, in the next few years, we're going to discover even more reflective planets out there, and something that's going to beat this record pretty quick. When it comes to finding unusual planets, there is quite a long list. Actually, there's an entire playlist of unusual exoplanets somewhere in the description. Some planets are weird for one reason. For example, there are planets that are too big, too small, too dense or not dense enough. Or, more recently, we've discovered a planet that was just a little bit too hot. As a matter of fact, hotter than the majority of stars in the entire Milky Way. But today we're going to be talking about another planet, an exoplanet known as 8 Ursa Minoris b that the researchers behind the study in the description have been basically describing as a planet that technically should not exist. A planet that somehow survived something that most planets do not. It somehow managed to survive the destruction by the star. Hello wonderful person, this is Anton, and so today we're going to be discussing this unusual planet, what the scientists believe might have happened here, and basically talk a little bit more about the mystery of a planet with a proper name, Hala. It's one of the planets that got lucky enough to receive a proper name. But in order to understand why this planet should not exist, we actually have to talk about the star first. The star that also has a proper name, and the name in this case is Bagdu. Bagdu and Hala, by the way, are the names of two biggest mountains in Korea. One of them is in North Korea, and one of them is in South Korea. And these names were proposed and accepted by the Korean researchers who originally discovered this exoplanet back in 2015. And so what exactly in the star system makes it kind of unusual? So first, the planet itself is not actually that special. It's about 1.3 masses of Jupiter, and it's also slightly bigger than Jupiter as well. It takes about 93 days to orbit around the star, with the orbital radius that's about half the distance of Earth to the Sun. It also has a relatively low eccentricity, or basically the orbit here is very circular, and overall the scientists refer to this kind of a planet as a warm Jupiter. A gas giant with a relatively hot upper atmosphere, but not hot enough to be considered a hot Jupiter. So definitely intriguing, but not super exciting. But the scientists analyzing this planet then actually wanted to see what the star is like. The star, once again referred to as Bagdu. Now this is an orange dwarf, also known as a K-type star. A star a little bit smaller than our Sun, but a star that seems to be much older. And so here the scientists wanted to find out what stage of the lifetime the star was in. For this they use a very well-known technique that you can learn more about in the description, known as astroseismology. This is actually a super cool technique based on the idea of seismology on planet Earth, where essentially by detecting various oscillations in a typical star, it then becomes possible to analyze what's happening on the inside. In some sense, it's like looking at starquakes. And this technique has been developing and improving pretty much every year, mostly based on helioseismology coming from our own Sun. So first by studying the Earth, and then by studying the Sun, it then becomes possible to study other stars. And that's essentially what the scientists in the study decided to do. And the main goal here was to try to figure out how old the star was and what period of its lifetime it was currently in. Turns out this was an extremely old star, basically almost at the end of the life cycle. And so by using astroseismology and looking at frequencies of waves coming from this particular star, it then becomes possible to find out what material the star is currently burning. And turns out that it's currently burning helium. And if the star is burning helium, it means that at some point it must have been much bigger. Based on modern research, we believe that helium burning process in these types of stars happens after the red giant stage that must have happened sometime in the past. And for stars like Bagdu, they're expected to reach a certain size when they become red giants. This is actually very similar to what our Sun is going to become in the next 5 to 6 billion years. And so by doing the calculations based on the type of the star, K-type, the researchers determined that it should have actually been at least 0.8 astronomical units in size. Or in other words, it should have covered the star's orbit, completely engulfing the planet in the process. In other words, at some point in the past, this planet should have been inside the red giant star. Yet somehow the planet survived, suggesting that it now entered the next stage. And the challenge here is, of course, how exactly did this planet survive this? And why is it that we're not seeing this more often in other systems? Well, the first, I guess, the obvious question was, well, was this planet even real? Maybe it was some kind of a data glitch and maybe this planet doesn't even exist? Or maybe something else was miscalculated. But turns out, after years of research, this planet has actually been confirmed to exist and seems to be the size and the mass that was originally suggested. The star and its current stage, which is helium burning, has also been confirmed independently. Essentially confirming that there's a planet that somehow managed to survive what we usually believe destroys planets. In the end, assuming a relatively circular orbit relatively close to the star. Here, as you can see, the star is actually really large in comparison to the planet. And by the way, in case you were wondering, this particular helium burning stage is most likely going to last for a few million years. Although because this is a K-type star, it might actually last up to 50 million years. So this planet is going to be here for quite some time. Eventually though, the star is going to release the entire outer shell as a nebula and become a white dwarf. Also, this is not the first planet discovered around a red giant stage, but it seems to be the first so far that's close enough to the star and should have technically been swallowed and destroyed. So definitely an intriguing discovery and definitely a very intriguing mystery. But do we have any potential explanations? Well, at the moment, nothing too concrete and nothing that seems to explain everything. For example, one of the explanations suggests that maybe this used to be a binary system. This could have been two stars that had a planet orbiting very close to them, and eventually these two stars merged, preventing any one of them from expanding large enough, and thus preventing the planet from being absorbed. But by itself, this would be very difficult to prove, and there's really no evidence for any of this happening otherwise. The explanation itself would go as follows. We had two stars with a relatively close orbit, which would eventually start sharing the material, with one of the stars eventually becoming a white dwarf, and then the second star eventually swallowing the white dwarf, becoming the merged star that we see today, that seems to have helium ignition that might have begun a little bit prematurely. Now that's a pretty intriguing explanation, but right now there's just not enough evidence. But the other explanation is a little bit more intriguing. The implication here is that maybe this particular planet formed as some kind of a remnant from the material that was expelled from the star, possibly once again because of a collision between two different stars, or because of some other violent event. In other words, the suggestion here is that this is a second-generation planet. It's a planet that was created at the end of the star system from all of the extra material that used to orbit around the star and got expelled in the process when the star became a red giant. A pretty intriguing explanation, but once again, there is just not enough evidence to prove any of this definitively. And so at least for now, this is going to be one of those exoplanets that's not really going to have a very good explanation for why it exists or why it was able to survive. Hello wonderful person, this is Anton, and today we're going to be discussing a somewhat intriguing discovery from one of the first planetary systems discovered by astronomers in the early 2000s. A planetary system that you can kind of see right here, visualized in Space Engine, with the planet somewhat similar to Jupiter, orbiting extremely close to its parent star. Just to give you better perspective, here's how close all of this is. But what's intriguing about this planet, or I guess what's intriguing about the recent discovery, is the recent analysis of the unusual tail created by the planetary atmosphere as the result of various gases, and specifically helium, escaping from the surface and forming something absolutely extreme, something that the scientists did not imagine. And specifically, the longest tidal tails ever seen around any planet anywhere. And so in this video, we're going to discuss what the scientists actually discovered, how they found it, but also why this is sort of exciting and somewhat unusual. But first, what exactly is this star system, and what exactly is this planet? In essence, this is what we refer to as a hot Jupiter. A planet that's somewhat similar to Jupiter in size and in mass, but that orbits extremely close to its parent star. A star very similar to our Sun, known as HAT P32, located at a distance of about 950 light-years away from planet Earth. And back in the early 2000s, the scientists suspected that there might be a planet orbiting around the star because of initial observations from the Hungarian-made automated telescope, also known as HAT. The project that started back in 1999 and was eventually joined by a lot of institutions around the world in order to basically discover various potential exoplanets. You can sort of see some of the initial telescopes used by this project in these pictures right here. All of them were relatively simple and relied on somewhat simple setups. And so around 2004, the scientists suspected that there was a planet around this star because of unusual jitters, eventually confirming HAT P32b as a hot Jupiter approximately 0.9 Jupiter masses, but about double the size. Or basically this was an inflated Jupiter, also sometimes referred to as a poofy planet. And though initially it was assumed to be because of distances involved, here it orbits around the star at just 3% of the distance of Earth to the Sun, the temperature alone unfortunately cannot actually explain why this planet is so inflated. Here the temperature is about 1800 Kelvin, which is just not hot enough to explain any of this. As a matter of fact, there are planets that are even hotter, but are much smaller in size. And this unusual phenomenon of inflated planets has been already observed around other planets, like this one right here, WASP-17b. And so there must be something else happening here but it's currently unknown what. Nevertheless, when this planet was originally found, it was technically the largest by size ever seen, and it took over a decade to find something even bigger. But because this is such an extreme planet, it's actually one of the reasons it was discovered so quickly without using more advanced telescopes. The final confirmation for its existence was done by the now retired Spitzer Space Telescope. But because this planet is also losing so much material, over time the scientists identified a lot of intriguing molecules, including molecules of water, inside the atmosphere of this strange planet. And all of this was possible for one simple reason. The orientation of the orbit of this planet is approximately 89 degrees. Or basically it orbits in such a way that we can always see it pass in front of a star, allowing the scientists to see some of this light interact with the atmosphere of the planet, but also obviously with its tail. And so apart from the discovery of water, they also started to find unusual detections of something else that was not inside the planet, but around it. Now first of all, they were able to confirm that because of the size of this planet, it's inflated so much that the outer parts of the atmosphere of this planet are now beyond its Roche lobe. In this case, the lobe itself represents a region around the planet where the planet can still gravitationally hold the molecules from the atmosphere. Whereas beyond this lobe, the gravity from the star takes over, and so the molecules start orbiting around the star and eventually possibly even fall into it. And so in this case, a lot of the material is already past the lobe, resulting in a huge loss of material that then creates this unusual tail moving away from the planet in possibly two directions. And so in this case, it doesn't actually resemble a typical comet as much as forms what's known as the tidal tails. Likewise, by observing the atmosphere as it passes in front of the star, the scientists were also able to discover a cloud deck and a variety of different haze that seems to form layers around this planet. So basically here the atmosphere forms unusual layers around the planet, with the planet itself potentially resembling something we've never even seen before, or something we currently cannot imagine. But it turns out that this is just the beginning, because the amount of gas that comes out from this planet is absolutely ridiculous. It seems to lose about 14 tons of material every single second, with the atmosphere leaking in several directions, which as a result produces these double tails that seems to extend up to about 53 times the planetary radius, forming the largest such structure ever seen around any planetary system out there. And although it was assumed that the planet was losing atmosphere, nobody actually knew by how much. Or more importantly, nobody expected the incredible size of these objects until it was actually physically measured. For example, just as a contrast, here's how this tail is simulated in Space Engine based on previous assumptions from previous studies. So basically it was always believed to be somewhat cometary in nature, or at least resembling something from a typical comet. But the more exact calculations and observations suggest otherwise. And here I think it's important to understand how the scientists discovered this. And so once again, it was because of the transits observable from planet Earth. As the planet passes in front of a star, here the scientists can observe various changes in starlight as it interacts with various gas. And it just so happens that even before and after the transit, some of the starlight seems to interact with some kind of a gas, as you can see here, for a period of about 12 hours in total. And this implies a really large cloud emitted from both directions from the planet. In this case, this was a cloud of helium, very likely coming from the planetary atmosphere. And so by putting the data in a 3D modeling software, the scientists were able to recreate something that looks like this. And since there's no other explanation for this unusual chemical fingerprint, at the moment it really looks like this planet is losing so much atmosphere that it forms these peculiar tidal tails, thick enough to dramatically dim the light from the star itself. But since the gas in this case is very similar to the planet, it's very unlikely to have come from somewhere else. Although obviously there's a lot of hydrogen here, but that could have come from somewhere else for sure. But by having both hydrogen and helium present in vast amounts around the planet can only mean one thing: the planet is basically evaporating. But once again, most likely not because of the heat from the star, but very likely because it's so close to the star that it's now tidally disrupted. And so this is really the result of tidal disruption, not so much heat. But even though it looks like this is a huge amount of stuff being lost, according to the recent calculation, it would still take this planet nearly 40 billion years to lose all of this completely. And so this unusual planet is unlikely to evaporate anytime soon, and will most likely exist for a very long time, doing the same, depending on exactly what happens with its orbit in the future. Although chances are the star itself might eventually swallow it over time. So definitely quite an exciting star system. But one question that we always had and cannot answer yet is of course if something like this happened around the solar system sometime in the past. Some previous studies have suggested that there was another planet in the star system, and it might have even been a gas giant that was possibly swallowed by the star, and if so, it means that it most likely emitted just as much gas. And so the question here is, what exact effects all of this has on all of the other planets in this star system? Does it actually seed the planets with a lot of other materials? Or does most of this gas just evaporate, leaving the star system over time? So definitely not something we can answer yet, but something future studies will probably tackle. Hello wonderful person, this is Anton, and today we're going to be discussing magnetospheres, and I guess more specifically, magnetospheres of exoplanets potentially similar to our own Earth. With the question being really simple, is our planet unique in its ability to produce the magnetosphere, or can other terrestrial planets, specifically planets that are not Earth or not planets in the solar system, possess magnetosphere as well? With this question being important for obvious reasons. Planet Mars. We know that Mars today very likely looks like this because it did not have powerful enough magnetosphere. Whereas Earth does, and so it's able to preserve both water and the atmosphere. And although in the past we've discussed magnetospheres detected around very large planets, very often hot Jupiters, or even brown dwarfs, in their own star systems, even without an actual star, this question has never been answered in regards to terrestrial planets, planets like Earth, but in other star systems. Or at least up until very recently. Because it looks like we now have at least one initial sign that a terrestrial planet orbiting a relatively close star potentially has magnetosphere after all. And potentially a very powerful one. And so let's discuss what exactly was discovered here, how it was found, and what this means for the future of astronomy. But I guess first, let's start with the star and the star system where all of this was discovered. This is actually a relatively close system to us. It's about 12 light years away, or about 4 times as far as the nearest star Proxima Centauri. And as you can see, it contains 3 known exoplanets. The star is known as YZ Cetus, located in the constellation of Cetus, or basically the constellation of Whale. But even though it's really close to us, it's practically invisible using any optical telescope unless it's extremely powerful. And that's because it produces less than 2% of optical light compared to the Sun, and because this is basically a red dwarf. And the thing about red dwarfs is that, statistically, they're more likely to contain terrestrial planets, and those planets are also more likely to be very close to the star, interacting with the star in the process. And the 3 planets discovered here are extremely similar in mass to planet Earth. The closest planet is actually the smallest at 0.7 masses of planet Earth. The second planet is a little bit more massive at 1.14 masses of planet Earth. And the last planet is about 1.1 masses of planet Earth. With all 3 relatively close to the star as well, with orbital periods between 2 and 4.5 days. And all 3 are maybe a little bit too close to the star to potentially host liquid water. Even the farthest planet potentially has temperatures of at least 90 degrees Celsius on the surface, very likely much higher. Especially if it possesses atmosphere that increases the greenhouse effect. But because all 3 are so similar to our own planet in terms of mass, and because they are so close to the star, and also on top of that because the star system is so close as well, it essentially provides a perfect laboratory to study the effects of these planets on the star, and to thus potentially discover what sort of unusual properties these planets might have in regards to, for example, magnetospheres. And in the past, from some of the previous papers, the scientists realized that there's actually a way for us to use observations using radio telescopes to possibly find effects of the magnetosphere around distant objects. For example, one exoplanet, HAT P11, orbits so close to the star and provides so many different effects on the star that in the past the scientists almost definitively confirmed that this very hot gas giant most likely contains a relatively powerful magnetosphere that then interacts with the star and produces very specific radio emissions. But in this case, the scientists are not really looking at planets themselves. Because of the distances, they can only actually see what's happening on the star. And so in this case, by looking at radio emissions coming from YZ Cetus, the scientists discovered something really strange. Very powerful bursts of radio energy that seem to have happened at least twice, and seem to be correlated with the orbit of that closest planet around the star, which by the way takes approximately 2 days. Or basically they've observed what's known as the stellar radio waves that seem to increase dramatically when this planet was in a certain part of the orbit around the star. And for this to be visible from planet Earth, these emissions had to be super powerful. And more importantly, to even generate these emissions, you have to have some kind of a magnetic interaction with another object. But I guess more intriguingly, the emissions coming from this object are super similar to what we actually see coming from Jupiter when Io interacts with Jupiter's magnetosphere. This particular study was previously used to discover very similar radio emissions from other, much larger planets in a distance. And intriguingly, we know that because of this interaction, Io tends to form a very specific footprint visible in the aurora in the northern hemisphere of Jupiter. Other moons form something as well, but it's not as easily visible. Which basically suggests that in this case, this particular star very likely experienced its own aurora as well. Aurora that were probably invisible in optical light, but very likely extremely easily visible in radio light. And that's because the star is just too bright for any aurora to be physically visible, but the radio light produced by these aurora would be much brighter and thus much easier visible. And what this implies is that this planet very likely has a very powerful magnetic field, and it basically interacts with the magnetosphere of the star itself. And just like Io, that produces these effects by moving through the magnetosphere of Jupiter, leaving behind certain marks in the aurora, it looks like this is exactly what's happening here as well. In essence, producing what the scientists refer to as extrasolar space weather. And though on planet Earth, the aurora are produced in the upper atmosphere and are not actually visible on the Sun, because of the overall proximity of the planet to the star and the direct interaction between their magnetospheres, the aurora seem to be produced on the star as well as potentially the planet, as long as it has some kind of an atmosphere. At the moment, it's unknown whether it does have an atmosphere, because unfortunately, unlike other planetary systems, in this star system, the planets do not pass in front of a star, so they don't actually allow us to see the little shadows that would allow us to study the atmosphere, and so answering the atmospheric question is not going to be possible until later. But because in this case it produces a very specific, extremely strong polarized light, radio light that's detectable every time the planet is in a certain position around the star, some of these questions could be answered in the future once there are more models investigating exactly what's happening around the star system and how this planet affects the star. In other words, by detecting some of these radio emissions, some of the questions in regards to the type of planet this is might be answered in the future. Although in this case, it's also important to understand that this is not a particularly good candidate for habitable planets. This is also what's known as a flare star. A star with quite a lot of attitude. These tend to produce ridiculously powerful stellar flares that are often much more powerful than anything our Sun can produce. And these planets are also very close to the star, so in theory, any planet here would be stripped of pretty much anything. Which means that studying the surfaces of these planets and trying to figure out what's happening around the star system is actually one of the more intriguing questions for future astronomy. Our universe is filled with a lot of different mysterious objects and a lot of different mysterious planets. But some objects we've discovered in the last few decades are more mysterious than others. Hello wonderful person, this is Anton, and today we're going to be talking about one such object we haven't discussed in quite a while. A strange and unusual object known as the Magnetosphere object, named after its original discoverer, the object that's located about 434 light-years away from planet Earth. But it's not this right here. It's actually around this star. So back in 2007, the scientists looking at this unusual star, or actually somewhat usual star known as V1400 Centauri, or more commonly known as J1407, discovered these unusual dips in brightness that really were difficult to explain. This is actually something that lasted for approximately 56 days. But unlike other stars that have experienced unusual dips in brightness, such as the famous Tabby star, and whose explanations involved the megastructures around the star, it didn't really take the scientists very long to figure out exactly what they were looking at here. By modeling the dips and trying to figure out exactly what they were showing us, the scientists behind the study realized that they were looking at enormous rings. And so it turns out that the Magnetosphere object was some sort of a giant ring planet, very likely the biggest rings in the universe, or at least in our galaxy. Okay, or at least the biggest rings discovered so far. And how big is big? Well, the calculations back then established this to be approximately 0.6 astronomical units, or about 90 million kilometers, or about just over half the distance of Earth to the Sun. so really big. But this of course also naturally produced a lot of different problems, such as, okay, how can such a ring system even exist? And more importantly, how can it actually stay stable? Well, the modeling paper did actually explain that it's possible for these rings to exist if they were to spin in retrograde motion, or in other words, if they were actually moving in the other direction from how the planet was orbiting around the star. And also back then, the scientists, by using SWASP that you see right here, also known as super WASP, were able to work out the overall properties of the star and of course the planet itself. And so the star was worked out to be relatively similar to our own sun, maybe a little bit less massive, and the planet was believed to be about 13 to maybe 26 masses of Jupiter, with a somewhat eccentric orbit between about 3.5 to maybe 13.8 years around the star, with the total mass of the rings representing something equivalent to planet Earth. And because this object also contained visible gaps in the ring system, this also implied that there were probably moons around this object. So this was officially one of the first discoveries of so-called exomoons. Even though the actual moons have not been seen, the presence of the gaps in the ring system indicated that it was probably produced by moons. And more specifically, this large gap visible right here represented a possible moon of about 0.8 masses of planet Earth. At least that's what the initial analysis indicated. Moreover, the analysis from 2015 also established that the rings can even grow larger or at least replenish themselves by tidally disrupting various comets that could actually get captured by this planet. And so this paper from 2015 definitively explained how such an object, Mamajek's object, could actually exist and how it could potentially exist for millions of years. But the thing is, the star itself, and also this object by extension, were only believed to be about 16 million years old. In other words, this is a relatively young star system. Moreover, a few other problems started to sort of appear over time. First of all, as I mentioned, it was expected that the single period here, single orbit, would take anywhere from 3.5 to maybe 14 years. But since its original orbital period was predicted to be anywhere from maybe 3.5 years to possibly 14 years, a lot of scientists expected that this object is going to reappear sometime in 2020 and maybe 2021. But nothing was seen last year, and nothing has been seen this year either. And for many years now, I've been kind of trying to find new papers or try to find new analysis just to see what the scientists discovered in regards to this unusual object. Well, a completely new paper just came out not so long ago, along with some of the other papers from the last few years. And here's what we know so far and what was discovered in these recent papers. First of all, one of the previous papers from 2018 decided to go through some of the older data as far back as 1890, so basically over 100 years ago, 130 to be exact. They looked at various old plates of the same star and tried to find as much possible data about the star as possible. And here they were only looking for one single thing. They were trying to discover any other dips, any possible dips, that could have happened in the past as well, while also combining this with some of the recent observations between 2012 and 2018. Well, nothing was discovered. Nothing was ever causing the star to lose its brightness. Then this other paper decided to do something a little bit different. They decided to take a direct look at this particular location by looking at all of this in other frequencies of light, specifically millimeter and submillimeter light that is visible using the beautiful ALMA telescope you see right here. But nothing was directly visible in the location where they expected this planet to be, or whatever this object was. They did, however, detect something a little bit farther away in a very different location. There was a tiny point, infrared point, visible slightly farther away from the star itself, with the observations being consistent of something that was actually not a planet, but instead was a detached object. An object that might have passed in front of a star and was now moving farther and farther away. And more specifically, these observations indicated that this was some sort of a thin ring of dust, with dust particles being around 1 millimeter in size, which was also indicative of some sort of a young ring system, but not necessarily this particular planet. And so definitely more studies were needed to try to discover what's going on here. And so now we have this last paper that was just recently released that went on a very thorough analysis and a lot of different investigations, this time really focusing on the star itself. Mostly because the scientists wanted to figure out what kind of a star this was to begin with, and also if there were any other planets around it. And so first of all, we already knew that this is a variable star. It does change its brightness quite a lot, quite dramatically, and quite frequently. But none of the observations in the last 19 years revealed any other dips in brightness or any other planetary objects passing in front of it. They also discovered that the star has a lot of different star spots on the surface, which can definitely affect the luminosity of the star. But in this case, the star spots alone would not be able to explain these unusual dips in brightness that lasted for 56 days in 2007. The star is also quite magnetic, has a lot of different emissions, and has a 5-point-year magnetic cycle that does change its activity. But none of the dips in brightness so far indicated that anything else was orbiting here or showed any other dips from the mysterious Mammajax object. And so, by combining the results from these studies, we can maybe start making some conclusions. And so first of all, it looks like nothing massive or nothing really large is really orbiting this particular star, at least not from the perspective where we can easily see it. It looks like in the last 130 years or so, there was only one major dip, and this dip was from this unusual object that passed in front of a star. But it also looks like this was a single event, it only happened once, and it's actually extremely rare for any of this to happen completely by chance. And it looks like this one dip that happened in 2007 might have been from this mysterious brown dwarf or some sort of a really massive planet with extremely large rings that very likely just passed in front of the star. And so here this would be what we would refer to as the detached object. A planetary object that passed in front of a star, caused all of these dips, and is now essentially flying through the rest of the galaxy on its own merry way. Something that was further detected in the infrared observations from ALMA, with the object itself moving at around 35 km per second and very likely simply just passing in front of a star. But we've always believed that these events would be extremely rare, and moreover, this object would be extremely unusual. If this is just a brown dwarf or some sort of a rogue planet with a really large ring formation, this would be quite an extremely rare discovery. So rare, as a matter of fact, that it sort of defies the odds. But for now, this does seem to be the best explanation. It seems to have been some sort of an unusual, brown dwarf-like or planetary object with extremely large rings around it, which technically makes it its own star system. And in this case, a lot of these ring gaps we've detected could have actually been, technically, planets around it. At least that's what it seems like so far. Nobody really knows truly what this object is, and we're not going to know until we see it again. And because the original predictions of the maximum orbit of this object predicted its reappearance sometime in 2020 or maybe 2021, and also because we haven't really seen anything since, especially in the last year or so, the only other reasonable explanation here would be, well, that it's a detached object, and we just got extremely lucky to see it pass in front of another star, with the object itself thus becoming even more interesting than the original discovery. At least scientifically speaking, it would mean that this is probably some sort of a baby star system, baby rogue planet system, or possibly an entirely new type of an object to begin with, something we haven't seen before and something we might not see for a while as well. Hello wonderful person, this is Anton, and today I wanted to come back and talk about one of the most iconic exoplanets ever discovered, the closest exoplanet to us, the planet known as Proxima b, a potentially terrestrial exoplanet located only 4 light years away from planet Earth, and a planet that was officially discovered only a few years ago. Naturally, since then, it created quite a lot of buzz in the scientific community, because the scientists wanted to figure out if it does potentially have conditions similar to planet Earth, and if there's any chance that it might be also habitable, or maybe even have life on the surface. And one of the most exciting discoveries coming from this particular star system only happened a couple of years ago, back in December of 2020, a detection of an unusual signal. A report of what's known as Breakthrough Listen 1, a potentially artificial signal coming from the same location as the star system itself. In other words, it seemed like someone was sending signals to us, but turned out that it was most likely coming from planet Earth based on further analysis. Very likely some kind of a reflection from a satellite, or something else entirely that did not seem to have extrasolar origins. But that of course highlighted how excited scientists are about this planet, and how many scientists actually believe that we do have a chance to find something on the planet, if one day we're able to see its surface, or if we can find a way to maybe visit this planet. And so even today, this is essentially the biggest discovery in planetology, and the most exciting planet ever found. But here it's important to understand a little bit more about the star system before we make any conclusions. First of all, this is a red dwarf. a star that's much smaller than our Sun, and a star that's much cooler in terms of temperature. And because of this, the actual habitable zone around the star is much closer to the star than in the solar system. Here you can see that it's much closer than the Mercury's orbit, which means that in this case the planets orbit so much closer to the star and thus receive so many different effects that Earth does not. We're going to discuss them in a few minutes. On top of this star is really dim compared to the Sun as well. It has less than 1% of total luminosity of the Sun, and most of the light that it produces is actually in the infrared. But it also has quite a lot of emissions in the X-rays and the UV light as well. In comparison, our Sun produces mostly optical light, the light that we can see with our eyes, and it also is the light that allows things like photosynthesis to happen on the surface. And so, in many previous studies, the scientists established that photosynthesis is extremely unlikely around a typical red dwarf, and thus evolution of complex life is unlikely as well, at least types of life we have here on planet Earth. Although there is a slight chance for photosynthesis using certain types of archaea or ancient bacteria, but that's still debatable. But because these stars are essentially the most common stars in a galaxy, with many of them potentially possessing planets very similar to planet Earth, learning more about Proxima Centauri has always been extremely important for a lot of planetary studies. Whatever happens here is most likely to happen in many different star systems in a galaxy. Okay, actually not many. Most planetary systems in a galaxy. The vast majority of planetary systems would very likely have similar conditions. And so many different studies have focused on trying to understand both the star and the planet. And so what about the planet itself? Well, from what the scientists established so far, it seems to be a little bit more massive than planet Earth, maybe about 7% more massive, but its actual properties are not really known. And that's because, unfortunately, we don't really see the planet pass in front of the star. We don't really get to see its shadow and thus study its atmosphere, or determine its actual size. Because of this, it's unknown if it has any atmosphere at all, and its density and thus its composition are not really known either. The only thing we know about it is that it seems to be very similar to a lot of other planets discovered around other red dwarfs, and so here only statistically can we determine what sort of planet this might be. And so technically, it could be some kind of a Mercury-like planet with a really large metallic core, but potentially no atmosphere on the surface, but it's a lot more likely to be some kind of an ancient ocean world. A planet with a lot of volatiles, or basically water-like substances on the surface, but maybe resembling something like this. Essentially what's known as an eyeball planet. A planet covered in ice with maybe a little bit of liquid ocean on the side that's always facing the star. And that's because this planet is most likely tidally locked. It's most likely always facing with the same side to its star. So one side is always bright, one side is always dark. Although it could also be just completely dry with only just a little bit of liquid water and maybe just a very thin layer of atmosphere. But all of this depends on the atmospheric pressure. If it has thicker atmosphere, it most likely does not have ice on the surface and has much more hospitable conditions. Although in this case we don't even know its actual orbit around the star. If it has a little bit more eccentricity, or basically if it's not entirely circular, this might create conditions where there's a lot of volcanism because of tidal effects. And volcanism might change everything, both the atmosphere and the actual habitability on the surface. Although volcanism could also change the internal structure and even shut down any kind of a magnetosphere the planet might have. And so in short, there's really very little we know about this planet right now, because there are not enough observations or even abilities to actually see it. But we can see the star, and we can study the star and thus try to figure out what it might do to any planet in the system. And that's what most of the studies are trying to do. And it turns out that the star is a little bit different from what we originally thought. This is a flare star. As the name implies, it's a star that once in a while flares up quite dramatically, increasing the emissions from the star anywhere from a few hundred to a few thousand times. And these types of effects can actually strip pretty much anything from the surface of any planet, especially planets really close to the star itself. And on top of being an extremely powerful flare star, this is also an extremely powerful magnetic star, with the magnetic field of Proxima Centauri being dramatically higher than our Sun. Here it's about 600 Gauss on average. That's at least 500 times more than the Sun. And so by placing any planet in the vicinity of a flare star with a powerful magnetic field, it dramatically changes what we now believe about the planet. It means that this planet is going to experience some ridiculously powerful space weather effects that no planet in the solar system has ever experienced. It means that this star, once in a while, every few years, launches super powerful blasts of radiation, bombarding the surface of any planet with all sorts of particles that in theory can strip anything from the surface. And if this happened in the solar system, planets like, for example, Jupiter and Saturn would barely even feel this because they're really far away. But here, Proxima b is super close to the parent star, and so these emissions would be thousands of times more powerful than even the most powerful emission in the solar system. Which basically means that it would be very difficult for any planet in the star system to possess any significant atmosphere, at least based on some of the recent discoveries. Now in theory it could still have ice and water, kind of similar to how we have ice and water inside moons like Europa, Ganymede, Callisto, and so on. But the actual planet would be extremely different from what we imagine. Actually, it might be kind of similar to what you see right here. It might be very similar to Europa, the moon that's always bombarded by powerful radiation from Jupiter, and the moon that also possesses quite a lot of water on the inside. But that's one side from one study. There are other studies suggesting other things as well, some things slightly more positive. For example, one of the discoveries was in regards to the type of UV radiation that Proxima Centauri receives. The radiation here is a little bit different from the one that Earth receives. It's a little bit colder or redder, and thus interacts much less with the organic compounds, but also possibly produces less ozone. Although because of different UV conditions, certain types of life, especially extreme life, could definitely survive, assuming that it's able to evolve here. And the other really exciting discovery is in regards to what's known as photochemistry, or chemistry produced by the star itself. Now we know that this is really important for the solar system and for planet Earth as well, and in this case, because of the proximity, there's a lot more photochemistry happening around Proxima b. And specifically, because of the type of the star radiation that this planet receives, there's actually a chance that the ozone layer, or even a lot of other atmospheric layers, could develop because of the chemistry from the star interacting with the surface of the planet. It might even start producing a colorless gas known as nitric oxide, and also quite a lot of oxygen as well, especially if there is some atmosphere that can actually encourage lightning strikes. These lightning strikes can dramatically increase the concentration of different gases, including gases like nitrogen and oxygen. In other words, because of the photochemistry, there is maybe a slight chance that this planet could be entirely different from what some of the more negative studies have assumed it to be. There might be a chance for some really incredible conditions here. On top of this, depending on the tidal effects that the planet experiences, it can actually also start having some other additional effects. For example, it might even acquire certain types of plate tectonics or various geological activity if it possesses just the right type of a tidal effect coming from the star. Now naturally these are just speculations, it's never been seen or proven, but the studies have determined that there is a slight possibility. And since M-type stars are very common and many of them do have these planets, the chance that at least one of them might have these effects is actually pretty high. So if not Proxima b, maybe some other planet. And if this is an ocean world, as it should be statistically, and if it also has tidal effects, this might then lead to other types of chemistry important for the development of life, chemistry related to the ocean tides. Basically here, the oceans encourage various types of chemistry, usually along the coastal side, as the water interacts with various sediment. Something that we do believe is really important for the evolution of life. And so, unfortunately, based on a lot of these recent studies, it's actually kind of difficult to come to a final conclusion on what this unusual planet might be like. A lot of studies seem to suggest that it's very likely inhospitable, and because of these super powerful magnetic and flaring effects, has actually been stripped of everything. But some other studies suggest that there is maybe a slight chance that there are other exotic types of chemistry going on here that could make this planet more habitable. Moreover, this is not the only planet in the system. At least one more planet has been confirmed not so long ago, with the third planet in between them very likely existing somewhere in the star system as well. One of the main focuses of modern astronomy is to essentially answer two questions about planet Earth. The first question is, what exact conditions were necessary to produce the planet that we live on today? And what conditions were then necessary to create life on the planet? With the other really important question being, can such planet exist somewhere out there, in our galaxy, or somewhere else in the universe? Or was the formation of planet Earth an extremely unlikely event, which by extension would make life itself quite a rarity as well? Well, we're not any closer to getting any of these answers, but in this video we're going to be discussing one discovery that presents us with a very intriguing star system that actually can take us a little bit closer to answering some of these questions. But I guess more importantly, potentially helping us discover something else really exciting. Hello wonderful person, this is Anton, and so today we're going to be discussing this relatively recent research that as always is available in the description below, where the scientists have once again discovered a very intriguing star system with quite a lot of similarity to the solar system, yet some very crucial differences. Once again highlighting the rarity of planet Earth. Although in this case, it's important to get a bit of a background. So basically, a brief summary of what the scientists have been discovering in the last decade or so. As you might already know from some of the previous videos, NASA has officially confirmed over 5,000 different exoplanets, with at least 9,000 more being what's known as candidates. But unlike previous predictions, so far the vast majority of planets discovered are somewhat different from anything we have in the solar system. There are quite a lot of gas giants discovered, but the majority of these gas giants are usually much warmer or sometimes extremely hot. There are also quite a lot of so-called super-Earths and mini-Neptunes discovered, and these planets don't even exist in the solar system. Yet they seem to be some of the most common planets in the rest of the galaxy. And terrestrial planets like planet Earth, Mars, Venus and Mercury seem to be extremely rare, and the majority found so far have actually been around red dwarfs. So stars like Proxima Centauri, the closest star with the closest terrestrial exoplanet discovered to date. But most types of life from planet Earth would unlikely to survive around any of these stars. They're just too active, produce way too much radiation, but most importantly, do not even produce the right energy for things like photosynthesis. So existence of complex life in these star systems is still quite debatable even today. And if the life exists here at all, it would be extremely different to anything from planet Earth. Nevertheless, missions like the TESS telescope have mostly been looking at these particular planets around these types of stars. But more importantly, a lot of modern research definitively suggests that having various chemical reactions on the surface might not be enough for complex life. It's also really important to have just the right type of architecture in the star system, including the right type of neighboring planets, in order for all of this to create the dynamic conditions necessary for continuous survival of life. And so, for example, in the solar system, Jupiter is believed to play a super important role in both protecting the planet from various destructive colliders, so the ones that would most likely wipe out everything on the planet, but also helping deliver much smaller colliders, smaller asteroids and smaller comets that would seed the planet with various chemicals necessary for life. On top of this, the migration of earlier gas giants, such as Jupiter and Saturn, may have even been responsible for the actual formation of planet Earth from different, much larger planets. So possibly even planets like mini-Neptunes, although this particular idea is still debatable even today. But the main point is that the actual architecture of the solar system is extremely important for everything that happens on Earth. Which is why some studies, instead of trying to focus on discovering terrestrial planets, actually try to focus on finding solar analogs, star systems with very similar planets to what we have in the solar system. And to be more specific, at least one gas giant, similar to Jupiter, a star extremely similar to our own Sun, but also possibly some other planets in the vicinity, but preferably in very similar location in the star system itself. And completely by accident, we seem to have one such discovery, at least one very promising discovery. The recently confirmed planet around the star Hipparcos 104045, approximately 175 light-years away from us, but, and this is extremely important, around a star that's very Sun-like, practically identical, only 3% more massive and 5% bigger than the Sun itself, but with extremely similar age of 4.5 billion years old. And very similar metallicity as well, so it's basically a solar twin. But this solar twin has a very exciting planet, two even. It seems to have a planet approximately double the mass of Saturn, and a little bit less massive than Jupiter, in around the same location where Jupiter is around the solar system, with an orbit of 6.3 years. A planet that, at least in theory, could have extremely similar effects to what Jupiter did in a solar system as well, basically guiding rocks around, redistributing materials, and protecting inner planets. But at the same time, there is a second planet here as well, in the location where we kind of expect Earth to be. Although unlike Earth, this is a very different world. It's something that's about 3 times as massive as Neptune and is most likely some kind of a smaller gas giant, with a total mass of about 43 Earths. In contrast, Neptune is about 17, but orbiting around the star every 317 days, or essentially in the area where in theory we may expect some kind of liquid water. With all of this discovered using HARPS, High Accuracy Radial Velocity Planet Searcher, that's been active for approximately 9 years. And unlike other telescopes, HARPS essentially looks for planets by using radial velocity, by looking at minute variations, periodic variations, in the starlight itself. And so as the massive planet, orbits around the star, it will usually produce redshift and blueshift effects. And in this case, 2 such effects were discovered, indicating 2 relatively big planets. But this is a really exciting program known as the Solar Twin Planet Search, whose main purpose is to only look for planets around Sun-like stars. And so far this is one of the most exciting discoveries. But even though the planet in the habitable zone is just a little bit too massive to be terrestrial and very likely does not actually have oceans on the surface, there is something else that can happen here. These massive planets will often contain moons, and in this case, a moon around this planet does have a very high chance to have liquid ocean. In other words, at the moment, this is probably one of the most exciting candidates for a potential discovery of an actual habitable moon. And if these moons are anything similar to what we have in the solar system, they're most likely going to have liquid oceans. Although assuming that these moons also follow a similar pattern to what we have in the solar system, they're most likely not going to be very big, much smaller than our own moon, and maybe something similar to Enceladus, one of the moons of Saturn. But as you might already know, this moon is essentially all liquid water, a huge ice structure on the surface and a huge ocean underneath, making this a pretty exciting discovery, at least for now. The problem is, of course, actually confirming this or even seeing this. The way that this was discovered is without looking at the planets passing in front of a star. Radial velocity does not actually require that. And so since we're not going to be able to see the transit of these planets in front of a star, identifying moons or studying their atmosphere, discovering the oceans here, or anything else would right now be extremely difficult, almost impossible, mostly because the technology is still not there. Nevertheless, at least for now, this is a really exciting discovery of 2 very interesting planets around an extremely intriguing star, and so we'll probably come back and talk more about this in some of the future videos once the scientists find something else. Until then, thank you for watching, subscribe, share this with someone who has learned about space and sciences, come back tomorrow to learn something else, and maybe support the channel on Patreon by joining channel membership or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.